Hello, welcome, and thank you for joining us today on the second day of BSides Mesh 21. Yesterday, we hoped that both red and blue teamers could find something interesting. We learned a lot about DevSecOps, container security, and the path there, as well as the human aspect of information security. And I'd like to take a few moments to bring the humans in our communities into focus. First of all, I'd like to thank our sponsors for making this conference happen. Please visit our sponsor channels. Our Argon, Krypton, and Neon sponsors have goodies prepared for you. So please check out the Greylog, Altego, Airbus, Cyrus, Google, Huawei, Ensight, Siemens, EFN-CERT, and Schutzwerk sponsor channels. We also have a lot of support from our Helium sponsors, which we would like to call out: the Hamburg Port Authority, Lotto24, Blaze InfoSec, YesWeHag, Exabeam, and Zipago. Please don't forget to visit their Slack channels for goodies. And you can also find out about opportunities at companies that support the InfoSec communities, for which we're very grateful for. I want to send a huge thank you to our speakers and workshop trainers for taking the time out of their very busy lives and jobs to share knowledge with us. And I'd like to extend this gratefulness to all the participants. You are investing your time in discovering something new and are actively taking part in the events, even under the special circumstances created by online presentations and talks and workshops and the corona pandemic. I'd like to highlight the fact that our community only benefits from a diversity of opinions and perspectives. Please be respectful to each other, welcome, coach, and advocate for every member to be successful. InfoSec itself is such a diverse field that each and every individual brings a unique contribution, no matter their gender, race, socioeconomic background, religion, sexual orientation, and many more dimensions. So we need to make sure that everybody feels welcome and is included. There are so many dimensions that I could probably take a full talk to enumerate how diverse our community is. I invite you to have lots of fun, and please exchange ideas, ask questions, take the Slack, and maybe update your Twitter following list. We're all a bit sad for not being able to meet in person, but technology these days has went quite far. So please take some time to talk to other people on Slack, maybe follow up with them on social media and such. Last but not least, I'd like to thank all the organizers. Everybody who made this event possible has spent tens to probably hundreds of hours across the Hamburg and Munich teams to make the event happen. You heard yesterday from Henrik that both BSides Munich and ElbSides are grassroots efforts started in the local MOOCsec and HA security meetups. You'll see many of us at the end of today raising a glass to hopefully a successful event. Since the first editions in 2017 in Munich and 2019 in Hamburg, our teams have been lucky enough to be stable or even expand, though our life priorities are changing. So we welcome new members motivated to keep a community event develop and answer the needs of each and every participant. And with that, I'll see you in a few moments. And we're back. Today, I am very honored to have next to me Jennifer Janeska, who has worked in various roles in information security for over 8 years, from penetration testing to securing critical infrastructure, to teaching security design hygiene to software engineers. Prior to her transition to information security, Jen worked for over 15 years in IT as a developer and leader in the areas of education, telecommunications, and semiconductors. She volunteers her time helping with BSidesMEsh, OWASP, and MOOCSec, and she enjoys hiking, running, and making CTFs and building smart things, or maybe breaking them. And then back to Jennifer, and we'll hear her presentation about InfoSec secrets.
Hey, my name is Jen Janesko, and I'm here today to talk to you about InfoSec's dirty little secrets. But before I get started, I'd like to take this moment to say thank you to BSidesMesh for having me today, for giving me the opportunity to speak with you all about a topic that I hold near and dear to my heart. I'm Jen Janesko once again. I am originally from the US, but I'm living here in Germany. I've been working in IT since 1997 and in the InfoSec space since 2013. I have had different roles within the space of information security. So I've worked as a penetration tester. I've done secure architecture and design. I've also done security reviews for critical infrastructures. And currently I work as a lead in a software security capability at a large retailer. And so without further ado, let's dive into InfoSec's dirty little secrets. So on this slide, you can actually see a number of different headlines. Now, these are all breaches. So health information breaches, personal information breaches, supply chain breaches, and also system breaches. And all of these breaches boil down to one root cause: credentials that have been publicly disclosed in the internet. And so usually the disclosure is through some sort of Git repository. And when I say Git repository, it's usually through GitHub or GitLab or Bitbucket. And so the focus of the presentation today is: how do these secrets get into the wild, and what can we do about these secrets? Now, before we even get started though, really, how big is the problem? Here we have a few examples of big breaches that occurred as a result of credentials being exposed. But really, is it a problem? Like, how quickly could an attacker really leverage a credential that's out there? And is it really a one-off kind of scenario? And so Andrzej Dijak actually had exactly this question. And in November of last year, he actually posted a really interesting Twitter thread where he dove into, okay, I am going to release some AWS credentials to both GitHub and GitLab. How quickly, if at all, will those credentials be used to compromise AWS resources? And so he committed the credentials to both GitHub and GitLab. And for GitHub, it was 11 minutes until compromise. In GitLab, it took slightly over an hour for compromise. That being said, slightly over an hour for a personal repository where credentials have been pushed to the repo is super fast. 11 minutes is amazingly fast. And so you have to think, in order for that 11 minutes to occur, there has to be scanning at scale being done for Git repos across the board. Then, in addition to this, in order for that 11 minutes to work, there has to be some sort of automation in place in order to check to see, is this a valid credential? And so those two things combined indicate that the attackers have taken the DevOps credo of automation to its fullest. Kudos to them, but it's super bad for us, the defenders, because 11 minutes to compromise doesn't leave us a lot of room for error. But really, okay, so the attackers have automation in place. They're looking for credentials out in the wild. They can automate testing to see if the credentials are valid. How widespread is this problem? So for this, I've picked out 2 studies for you. So in 2019, some researchers from the North Carolina State University put together a study, and they looked at GitHub only. And in GitHub, they found for easily fingerprintable secrets that slightly over 500,000 had been leaked into the wild. Of those slightly over 500,000, there are slightly over 200,000 that were unique. So that's 200,000 unique credentials out in the wild in 2019 in GitHub. So fast forward to 2021, there's a company called GitGuardian, and they did a study from 2017 to 2021. And keep in mind, GitGuardian sells services, so secrets management and secrets detection services. But they did a study, and there, in the past year, they've seen an increase of 20% of secrets being exposed in GitHub. 20% increase. So we have automated detection and exploit. We have increase of secrets being exposed. As an information security professional, I just want to shake my fist at the universe and scream, why can't we get this right? Why can't application engineers keep their secrets out of the Git repos that are public? So we're going to take a look at that a little more closely now, because if we can answer that, maybe we can figure out a way to help them so that it doesn't happen as often, and we can reduce the likelihood that a breach can occur that will result in PII data being compromised, supply chains being compromised, or other systems being compromised. So meet NG. NG is our application engineer, and NG works for a pretty big company, and they have a really cool app, and the customers who use the app really like the services that are in the app, and this app generates quite a bit of revenue for the company. NG is super proud of working on this app, works very closely with the product owner to develop the features that have been prioritized for the app, and to gain feedback from the customers so that they can improve the features. NG really likes actually building apps because it's building something from nothing. It's building something from code that people can use and actually benefit from. And NG is super proud of the work that they've been doing on this app. But a security review was performed on the app, and the security engineer working on this review noticed that NG had accidentally pushed code to their public repository, their personal public repository, and in it was a database password for the application. Now, NG remembered actually pushing that code out to their public repository. They wanted to actually take some of the work that they had been doing internally, push it out there so that they could actually open source some of it. And so once NG realized that they had accidentally pushed that database password out there, they went into the code, they deleted it, they committed the changes and pushed it to the repository, and NG felt like they were done. But the security engineer came back and said, oh, no, you can't do it that way. What about the Git history? When I run a scan, I can see that you've removed it from the latest commit, but in the Git history, that password is there multiple times. So what about that? Now, NG, a little bit enervated, but not completely beaten down, decides, okay, I need to figure out how to clean out my Git history so that this password isn't there. So spend some time Googling, reading through some Medium articles, and then did some trial and error, and then actually was able to delete those passwords from the public repo. Now, the entire history was no longer intact from that particular repository, but the passwords were gone. And so from NG's perspective, the history is clean, and so there's nothing more to worry about. Or is there? NG started to think, okay, I accidentally pushed this code to my personal repository, which was public, and that database password was there. There's nothing stopping me from accidentally doing that again. So maybe it's the case that I shouldn't be storing my database password in my Git repo. Okay, so then NG spent some time looking online to see, okay, what are some options? And one of the options that made NG most comfortable was the option of storing the database password in an environment variable in the production server and manually setting that up on deploy. That way, the database password wouldn't be stored in the Git repo, and so it would be safe from being accidentally pushed out to the public. And then it would be self-contained in the production server. But the security engineer came back and said, you should not and don't store your application secrets on your production server. If an attacker were able to compromise that server and gain access to that server, the attacker would be able to gain that clear text password straight out of the environment variable and then use it to access all of that private data stored in that database, just as if you had released that password out in the public. So I'm going to take a second to stop here. We need to take a breather. And we need to think about the way that the security engineer has been interacting with NG. Think about the language that the security engineer is using. You shall not, don't, you shouldn't. These are all negative formulations saying what NG should not do. But NG doesn't make money for the company by not doing things. NG brings value to the company by creating things, by doing things. And so at a minimum, as an information security engineer, we need to start saying, you should do this. You should. By telling an application engineer what they should do, it gives them the opportunity to go and exercise that possibility. It gives them direction of where they should look to solve the problem. And there are many information security engineers who already get this. And there are some people who are sort of changing and crossing the line and realizing that this is the way that we need to start talking to our application engineers so that they have the possibility to secure all the things. And the first step, or the common step, when you start talking you should, and this is what you often see in security reports, is referencing standards. And so here in this case, we have an OWASP top 10 proactive control. And the control is protect data everywhere. And if you look at this control, there's actually an entire paragraph dedicated to application secrets and how to manage them. An entire paragraph. Think about that. Application secrets management is actually quite a complex topic. But there's a paragraph there at least, and it says you should. And in that paragraph, there are a list of things that should be done with a couple of examples of what could be done, although it lacks context. But when we're thinking about how to manage an application secret, we actually need to take a step back and think about, okay, I have this secret, but really, what kind of secret is it? Because an application secret, depending on what kind it is, will require different types of treatments. And so, does it have crypto material? So are there private keys involved? If so, then maybe we need to think about an HSM. Is it a build secret? This is a type of secret that you use to actually deploy the application, to allow you to assemble the application and push the code and the system out to whatever environment for deploy. It is only used during the build process. And so if it's that kind of secret, then it probably belongs in the build environment and needs to be managed in a very specific way. Is it the type of secret that's a runtime secret, the type of secret that allows a particular system to access another system, get information, or initiate some sort of processing so that the customer using the application can do dynamic things within the application? If that's the case, then it's a runtime secret. And in this case for NG, it is a runtime secret. So the database password allows the application to go access a data store, pull data from it so that it can build a dynamic experience for the customer. Runtime secrets are often managed within application secrets managers. And so when looking at the slide on the top right-hand corner, there's a list of 4 different application secrets managers there. So AWS Secrets Manager, GCP Secrets Manager, HashiCorp Vault, and Azure Vault. These are 4 different secrets managers made for 4 different contexts. So these may not even be applicable for NG's context. So if NG is running in Alley Cloud, these may not actually apply. There may be something specific to Alley Cloud that NG wants to look at. So this problem space becomes quite complex quickly, depending on the type of secret that you're managing, and then also what space you're working in and where your code is going to run. And so to give you an example of how this complexity turns into time, I was recently speaking with a friend who's wise in the ways of application security and wise in the ways of application development. And it took him 1 week to figure out how to connect his application to the secrets manager inside of AWS so that he could actually interface with that and actually get the secrets out so that it could be used during runtime. 1 week. Now, compare that to setting up the variable or the database password inside of an environment variable, where it would take 2 to 4 hours to set that up and get that working. 1 week versus a half day. Keep in mind that NG is going to be evaluated on the features that NG delivers to production and the benefits and the feedback that come from the customers. 1 week versus a half a day. If NG is under pressure, NG's probably going to go with that half-day option, not the secure option. We need to figure out a way to reduce the security friction so that NG can deliver security value and feature value at the same time. Now keep in mind that 1 week didn't take into consideration other application security issues like creating strong passwords, generating random values securely, sharing secrets securely between teammates, managing access to secrets once they're in the various places, deploying secrets securely, rotating secrets, retiring secrets, and recovering secrets. This is all part of the secrets management lifecycle. And if NG spends a week on each one of these things, no features are going to get developed. Customers will stop paying attention to the app, and the company will start losing profit. And then maybe NG's job goes away. And this is not something that we want for NG. We don't want it for the app that's out there because it's generating the revenue that's paying our paychecks as well. So we need to figure something out. We need to reduce that security friction. So we need to give our application engineer some options. When I say this, we need to reduce the problem space for the engineers so that they have limited options for their context, limited good options for their context, which reduces their lead time to secure changes for their application. So they should be able to deliver the application in a secure way with the least amount of security friction from within the development process. Which leads us to information security's dirty little secret. We can't know, as information security professionals and engineers, all of the options for all of the contexts. But we still need to help secure all of the things. This is a conundrum in information security, where as an information security professional, people often look to you for all of the information security answers. And the challenge with that is there are so many different languages, there are so many different frameworks, there are so many different build environments, there are so many different target deployment environments. There is no possible way that one person can know them all. And so we need to figure out how to work with our application engineers so that we can give them the options that they need in an efficient way and not put too much pressure on ourselves to know all of the things. So how do we get there? How can we tell them, here are some options in an effective and an efficient way? First, we're going to start small. Pick something doable. I don't care what it is, but pick that one thing or that small subset of things. Pick something small that you want the application engineers to be able to do, and then define it. If you don't have any ideas, look to some standard that's going to give you sort of a maturity model approach to organizing the way that you roll things out. So here, for example, we have the software assurance maturity model from, once again, OWASP. And you can see that this is actually a scaffolded approach to secrets management. There's maturity level 1, 2, and 3. And so if you don't know where to start, go to SAM, look at maturity level 1, pick a small subset of the things from that list and roll it out. Try it. Work with some teams, but first select and verify whatever tooling you need before you actually start doing the rollout. If you don't have the right tooling in-house, make sure that you get it. If you don't have enough of the right tooling in-house, look to see that you can get more licenses or figure out how teams can get more licenses. Make sure that you have the right things in place before you start saying, here are your options. Because if you don't have the right tooling or a way to get the right tooling, they don't have the options to use it. So make sure that you have that in place. It seems simple, but it is absolutely imperative that that part is squared away. Remember, we want to reduce the friction from securing all of the things. Have the right tools in place. So for example, if you wanted the teams to actually start scanning their code for secrets upon commit or push to repository, then you need to look at, okay, what tools are out there? What tools fit with the different contexts of the teams? So the right operating systems or the right build environments or the right frameworks or the right languages, what functions with what, and then make sure that you've picked the tooling that will fit the context If you don't know what the context is, work with a couple of teams to figure that out so that you can make sure that at the start you have the right tools to actually fit what the teams actually do. Then, once you have picked something to do and tooling to support it, trial it with some teams. Don't do all of the teams at one time. Pick a few teams, a few key teams to help you figure out, does this approach work? And when you're picking the teams, you can think about trying to pick a variety of teams so that you can get different kinds of feedback from different teams. Try teams with different languages, or try teams with different build tools, or try teams that use different frameworks, or try teams that use different methodologies. Take a look at your application security landscape and your application development landscape within your organization, and then try to pick key teams who are going to help you build that profile and help you test the solution that you're suggesting. Once you do that, collect feedback from the different teams. And if it works and you haven't rejected the actual approach that you initially picked out, document the success. So document the things that work and how you got it to work. Document the things that didn't work and what the team should avoid. Also, curate any code or configuration artifacts that come out of the process. So why do we want to do this? It all boils down to something called internal search. So there is a study called The State of DevOps, which comes out on pretty much a yearly basis. And it's from an organization called Accelerate. And what the study does is it focuses on high-performing DevOps teams or high-performing agile teams. And it looks at their practices and what contributes to their success. And one of the things that contributes or actually adds to the productivity of teams is this thing called internal search. And this is where teams internally share good practice and they share good code examples so that other teams within an organization can pick up those good examples and build them into their own code base and into their own products. And by doing this, what they do is ensure that it's easy to find. They can actually employ it and it fits their context because it's usually the organization context. They worked because it's within that specific context. All of the niggly problems of onboarding and getting things to work have been worked through by another team. And so you have kind of a streamlined way of onboarding to a particular process or a piece of code. And so this is called internal search. It speeds up everything. So if you can somehow build the security process that you have worked with other teams to refine and make better and to make code available for, make it available in that internal search so that other teams can take it, build upon it, amplify it, refine it, and make it even better. Once you've gone through that process and you have something working and in place and it's being amplified and it's being replicated and it's being improved, repeat the process. Go back to the beginning, pick out the next thing and start the process again. Don't worry about the fact that initially it's only going to be a little bit that you're implementing. That little bit is more than where we were when you weren't doing the implementation. And over time, if you keep repeating and keep building, you're going to build up a set of practices that are doable by teams, that teams are actively using and actively improving. And in this way, we end up fighting against information security's dirty little secret. We can't know it all. We have to work together. We have to join forces with our application engineers, and we each need to use each other's strengths to secure all of the things. We need to be avoiding "you shall not." We need to avoid "you should," and we need to get to "here are some options," so that we reduce complexity and we improve lead time to secure changes. When all is said and done, we will have worked with our application engineers and we will have secured all of the things. Thank you for your time today. I hope that you have a great rest of the day. And yeah, I hope to see you again next year.
And we're back with Jen, who talks about the anatomy of the secrets lifecycle. And we have a few questions on our InfoSec Dirty Little Secrets Slack channel. The first one is from Morton, who's wondering if it would have been easier to invalidate the credentials instead of purging the Git history.
That sounds like an easy task. And in theory, what you would want to do is naturally invalidate whatever credentials that you have, that you've exposed, because that's the easiest way, very clearly, to make those credentials not usable. The challenge with that is there are a couple of challenges with that. There are some systems where you can't change the credentials. And so in those cases, you definitely want to extract the credential and get rid of it as quickly as possible. There are other cases, though, where that credential that you've exposed, you have reused, or your team has reused. Teams tend to reuse credentials, even though that's not good secrets management, and which is another aspect of secrets management altogether, is having different credentials for every system. Yeah, so if you've reused that in different places, it may be difficult to know, first of all, where all of those places are, but then to go into all of those systems and to invalidate the credentials. So your best bet is remove it, invalidate it, and hope that you haven't accidentally reused it somewhere.
So all of the above. Well, I have a follow-up question. You were talking about sharing success stories, and I really like that the presentation has a situation that didn't go so well. Do you have tips for how to share things that went wrongly, particularly in situations when the development team and the security teams don't trust each other?
So that actually is a really hard question, and that's actually very often the case. So where the security teams and the development teams are at loggerheads, because the security team is putting all of these requirements on the application engineers, and the application engineers, of course, want to do a good job, but they can't fulfill all of the requirements that security is putting on their shoulders. And so there are different expectations and capabilities to actually meet the requirements or the expectations of the security people. And so there's this imbalance. In these cases, that like solving that bigger problem is a cultural change. And it's best if the security organization can figure out a way to partner with the development side of the house so that you can actually secure things together. But in the cases where you are actually at a point where there is this lack of trust between the two organizations, you need to find some standard mechanisms to allow both teams to be able to analyze the situation in a structured way so that you don't end up having blame. Blame is probably the worst thing that you could have in those kinds of situations where a breach has actually occurred. And so there are definitely protocols that you can search for online for blameless postmortems, where you actually go through and you look for root causes where nobody is at fault, but you look for what is the behavior or the condition that caused the behavior to lead to the problem. You can look at the 5 whys, so asking why is it this way? And when you get that answer, ask, well, why did it happen that way? And once again, you're trying to drill down to what is that root behavior, or what is that root condition that caused the breach to begin with.
Thank you so much, Jen. We have 2 additional questions that I think that it's best that you answer on Slack, one about gray listing and one about scanning for credentials as part of CI/CD. The slides will be shared as well as the recording. And we want to thank Jen one more time for being our keynote speaker and sharing such an interesting situation, and I guess something that many of us have been meeting in our daily jobs. I'd like to call out that our awesome sponsor, Inside Attack Logic, has a raffle of Raspberry Pi starting now. And please join the Inside Attack Logic sponsor Slack channel to participate. Introduce yourself shortly and tell us what your interests are in the InfoSec community. And with that, Jen will actually be switching hats and will become a moderator for the next session. So see you in a moment.
Hey, InfoSec fans, we are back with BSides Munich. Welcome back. And right now we are stepping up and we are going to welcome Mathieu Gaucheler and Florian Murchet. So hey guys, how are you doing?
Hi.
Very well,
fine.
Great. We are about to have a really cool presentation from both of these gentlemen. Called No Distribute Scanners, a perfect testing ground for malware developers. So sit back, actually don't sit back and relax, actually jump into the Slack channel, ask some questions and pay attention because this is actually a super interesting topic. So let's see the presentation.
Hello everyone and welcome to No Distribute Scanners, a perfect testing ground for malware developers. So in this presentation, we're going to introduce ourselves, why we chose this topic. We're going to have an overview of the no-distribute scanners, how they are used by cyber criminals, and we're going to end this presentation by taking a look at an example of an investigation. So my name is Mathieu Gaucheler. I am a subject matter expert at Montego, and I have a background in malware analysis.
Hi, my name is Florian Murchet. I'm also a subject matter expert at Montego, and I have a background in digital forensics and incident response.
So what are no-distribute scanners? So first of all, NDSs, no-distribute scanner, are also called counter antivirus services by some other organization, like Europol, for example. So they are a scanner, meaning that they will match a file against several antivirus services. But the main difference between this website and, for example, VirusTotal is that VirusTotal will be sharing samples with their partner. This is why it's not very interesting to use VirusTotal for a threat actor, because you do not want your sample to be studied, you do not want your sample to be shared, even before you release them in the wild. At the time of writing, there was about 24 NDS that we know of, and 6 of them were active. This concept of no-distribute scanner has been around for It's a bit more than a decade now, and so far, as we've seen, it has only been marketed to cyber criminals. So we broke down the use of an NDS in 3 different parts: submitting your file, how the NDS is going to analyze it, and then how the NDS is going to report on it. So we're going to break these different steps in the next slides. So the first one is submitting a sample to an NDS. So you can do so by using an API. Like here, we have an example of the DINCheck API. It is a script running client-side to upload a file to DINCheck's backend. And on the left, you have a screenshot of CyberSeal, a cryptor developed by the same threat actor behind Data Protector. A cryptor is a type of software that can encrypt malware to make it harder to detect by security programs. This threat actor decided to create their own NDS and integrate it into CyberSeal, meaning that every time a threat actor was using this cryptor, they would have the result of this encryption checked on the NDS against several antiviruses. So that's how APIs are used in an NDS. But the most common way to submit a file to an NDS is by using their website. Every NDS has a website. They usually contain information about the pricing, what kind of scans are available, and some publicity sometimes. So on the left and on the right, you have 2 screenshots of a submission panel for an NDS, 2 different NDS. The one on the left is pretty simple. You can upload a file and that's it. Whereas the one on the right is more complex. You have several options to tweak the analysis and have it closer to the condition that your malware would encounter in the real world. You can also choose against which antivirus your malware is going to be matched against to replicate better the condition that your malware is going to encounter. But the main difference between these 2 NDS is not actually the complexity of their submission panel, it is the type of scan they offer. The one on the left is offering static scans, whereas the one on the right is offering dynamic scans. So what is the difference between these 2 types of analysis? Well, static analysis or static scans are basically anything you can do on the file without running it. So this can be, for example, string analysis, like a YARA rule, simply, or checking the export of a portable executable, or checking the entropy of a file to see if it is packed or not. It would be pretty easy to run such an analysis. You just need to have some AV installed, and then you would use the command line to run an analysis on a file, and you pipe the output of this to the NDS website, and that's it. You would have your analysis up and running. That would be also very easy to update your antiviruses. You could all have them on the same machine. Whereas a dynamic analysis, you actually need to run the file. And that includes, that gives us a lot of problems if one wants to run a dynamic scanner, because that would entail to have 1 machine per antiviruses, because if you run the same 30 antiviruses on 1 machine, they're going to parasite each other and parasite the analysis results, so you don't want that. If you want to run a sample against 30 different AV, you will need 30 different VMs, so it's a lot of processing power. You need a way to revert this analysis, to revert these virtual machines back to the way they were before the analysis, so one analysis does not parasite the next one. And you also need to find a way to update daily these antiviruses. So it's a lot of processing power, it's a lot of logistic. That is a lot of things that you need to do compared to static scanners. And this is why there are fewer websites offering dynamic scans compared to static scans. So we saw how to submit a file to an NDS. We saw how it was going to be analyzed. Let's take a look at the reporting. So on your screen, you have 3 different kinds of reporting. On the left, you have the simple web page. In the middle, you have an image that you can share, a .png. And on the right, you have several textual representations that you could use to embed these scan results in a web page or in a forum post. It's also possible to use the API to get the analysis results. Let's note that while some NDS offer all these ways of reporting, the main way and the one that is always available on every NDS to report an analysis is the web page. Every time someone uses an NDS, they are going to be given a link to the analysis result that they will be able to share afterwards, and everyone with access to the link can access the analysis results. So what are the business models used by NDSs? Basically, you have three types of plan. So the free scanners that offer static scans only. They seem to make money on ads. Then you have the paper scanners that offer both type of scan, dynamic and static. Although there is a big price difference between static scans and dynamic scans. Static scans are going to be around 10 cents, while dynamic scans are going to be around $3. So this huge price difference is explained by the difficulty to run a dynamic scanner. And then you have a subscription-based one for which you pay for a day or for a month, and you have access to a certain number of scans. So you have a lot of different subscriptions. They range from $15 for a day or $300 for a month. Then to pay for actually these services, to actually use the NDS, you can use different cryptocurrencies, but also some of them actually use some online payment systems like PayPal, BitPay, or WebMoney.
Thanks, Mathieu. And now, as we know how NDSs are working, we talk about their usage. The first is marketing for cybercriminals. Here they make use of NDS reports by showing that their malware is evading antivirus detection. It is most likely used for malware as a service promotion and advertisement because it is a selling point to convince customers that they don't buy burned malware or fake services. This also generates the trust between the provider of the malware services and the customer. Another common use case we assume is development of malware. With the capabilities of using APIs to test malicious software for detection, it will speed up a successful development process for malware. Another aspect is to use their API capabilities in malware tools, like the CyberSeal crypter, which Mathieu was talking about, which enables user to test their directly generated or packed or crypted malicious code in the same tool. Lastly, others. We assume in this use case group individuals which are testing their software and tools. It could be that red teamers and penetration testers test their tools before an engagement and most likely will burn them after usage. Then we have crackers, which proves that their software is not detected by the antivirus software. On the next slide, we have features that support the previous main use cases. The first one is the AV blocklist checker, which will detect infrastructure exposure and report the bad guys at their domain, which maybe is used for C2 communication, as burned or published. Also, the periodic scans, where bad guys can make use of during campaigns to check if their sample is burned by VirusTotal or different other antivirus software detections. Then now back to Mathieu, and he will tell us something about the user base.
Thank you, Florian. So what we did is that we wanted to explore if these NDSs had a specific community and were used by specific language users. So we took basically the domain of these NDSs, added them in Maltego, and searched Flashpoint data for posts mentioning them. Then we tied this post to forums, which gave us a breakdown of which forums were used the most to talk about which NDS. So that is the graph on the right. And on the left are isolated part of that graph, the top 3 NDS that are on the top 3 on top right, and the forums that talk about them the most. So this gives us a language breakdown for each NDS by observing the language of the top 3 forums in which these NDS are cited. So for example, for DINCheck, on the top left, the top 3 forums talking about it are Russian-speaking, English-speaking, and Russian-speaking. On top right, Virus Checkmate, you have English-speaking, Russian, and Brazilian Portuguese forums. And on the bottom, for nodistribute.com, you have Arabic, English, and Brazilian Portuguese. So from there, you can see that each NDS is more used by a certain linguistic community.
Thanks, Mathieu. I will dive into a short investigation on the data which we currently have. In this example, on the next slide, we found a post of the tool Xtool 3, version 3, which is a hacking tool, and the features are of it. It's generating usernames out of leaks and also the passwords. It also can scrape proxies from different sources. And it also can try to crack the accounts. So in this case, we found a post on the null.to forum where a stranger posted this tool with also the antiscan.me report to prove that this is not detected by an antivirus software. On the next slide, you can see that we also found this example of Xtool 3 with a different name, with wextract.exe and then a little bit space and then .mue on VirusTotal. The file name itself, it's pointing to the wextract.exe, which is integrated into Microsoft system features for extracting archive files. Also, we found that this tool makes some communication to different domains. Unfortunately, during our investigation, the domains were not available, but we can see in the history that this domain has also served some other malware samples, which are tracked by VirusTotal. On the right side, you can see the cracker alias, which is as a string in the code. And you can see that the stranger or the alias is Kirmada. And he has distributed this code on cracked.to. We found this example also on the null.to forum, which is referred by the recorded future document on the right. That's it for the first part of our investigations. We're trying to generate more data and working on this currently. And if you have any questions, give us a shout and just send us a message on Twitter or directly on LinkedIn or now.
All right, so thank you, Florian and Mathieu, for that presentation. We naturally have some questions for you, and so I hope you both are ready, and I hope you're holding on to the table. So some of the questions that that came through the Slack channel, the very first one, and I think you may have addressed it in the presentation, but let's just ask it anyway. Is an NDS like a sandbox?
Yeah, so we already addressed this in the presentation, but basically you have two kinds of NDSs as we showed, like the dynamic one and the static one. So to run a dynamic one, our suspicion, our very strong suspicion, is that you do need some kind of system like a sandbox to execute your sample in secure environment, to be able to reset it for the next analysis, to be able to update the AV in a correct way, and to provide a satisfactory analysis, you would need some kind of sandbox.
Okay. Great. Okay, and then the next question is, so are there some NDS providers? So you've talked about all of these people who provide this as a service, or these organizations that provide it as a service. Are there any NDSs or services that have emerged as leaders within the field? Like ones that seem to be the standard go-to for people who would like to make sure that their malware will be basically accepted.
Yes, Florian, you want to take this one, or should I?
You can go on.
All right then. Yeah, definitely. One that has been surviving throughout the years is DINSCAN. Basically, it has been around since 2016, which is pretty big for an NDS, big longevity right there. And it is the only one, to my knowledge at least, that has survived throughout the years and that is offering dynamic scans. For the static scans, nodistribute.com seems to be in the lead if we just look at the messages that we have data from companies such as Intel 471 and Flashpoint, and they look at the messages on forums, public forums, and so on. And nodistribute.com is the one that usually comes up in the lead for static scanners.
Super interesting. Okay, and then I guess we have time for basically one more question, so let's get to that. I'm reading here. You introduced some investigations that you're doing at the end of your presentation. What is your long-term goal or your big picture goal for these investigations, and where do you hope to go next?
I can go. We're trying to get more data from the anti-no-distribute scanners and try to find some really interesting samples. We found also there are people who are providing the for example, macro or document vulnerability exploits and sending this out and providing this as a service for selling this. And we try to find more because some of them we have found are not distributed to VirusTotal, so they are unknown. So that's vulnerabilities, they are out there, and maybe we want to track them and find the relation between them, and also how much are out there which is not in VirusTotal and maybe used in the wild. And yeah, cool. That's the
So, well, thank you so much. There are a couple of questions that have come through in the Slack channel since we've started talking, so please take a look and answer those. Yes. Thank you so much for your time today. Thank you for the talk. And we're going to take a few seconds now, a little break, and we'll be back shortly with our next talk. So thanks once again, guys.
All right. Thank you for having us.
Bye.
All right, so we're on to our next presentation. This presentation is from, let's see, it's from Itzik Mantin, and he is a security researcher who's been doing research, or actually been working in the information security space for over 20 years, and he holds roughly 20 patents. So he is a very busy person. His talk today is AI in a minefield, learning from poisoned data. And unfortunately, he can't be here directly with us today because there's something that's taking him away and preventing him from being actively participating. But we have Jonathan Azaria with us today to answer questions. So hey, Jonathan, how are you doing?
Hi, thanks, Jim. Hi, everyone. My name is Jonathan Azaria. I work in the same company as Itzik. I'm a data scientist. We've run this presentation together before, so I'm just going to answer questions once Itzik's done talking.
Okay, super. Well, then sit back or jump into the Slack channel, listen to this presentation, which is super interesting, and we will check back and ask questions afterwards.
Thank you for joining me in the talk about AI in a minefield, learning from poison data. I'm Itzik Mantin, lead scientist at Imperva. In the last 21 years, I've been innovating on security algorithms and their intersection. I love math, I love algorithms, I love the game of understanding threats and designing mitigations. And you can see a couple of pictures of what I do in my spare time. I will start with speaking about AI and the AI threat landscape. I will then zoom into the threat of data poisoning, about when, why, and how this threat is applicable and what can we do about it. I will then speak about how the data poisoning threat is realized or potentially be realized when building a web profile for the sake of web security. And we'll end with summary and conclusions. No doubt we are in the AI era. Artificial intelligence systems are everywhere and are changing the way people do almost everything. And the AI era is in fact also the data era, because data is the fuel that makes all these AI systems work. And AI and data have huge contribution to many domains. However, this contribution comes also with several caveats, which we tend to ignore, or at least to underestimate. And we'll speak about some of these caveats in this session. Most of you are probably familiar with the Gartner hype cycle for new technologies. So equivalent to this, you can think of a security life cycle for new technologies. New technology begins with very little thinking about security, or maybe no thinking about security. People are focused on the technical obstacles and are excited with the applications and the opportunities. At some point, someone discovers that this technology behaves very odd when certain input is being fed to it, and then you have another vulnerability and another one when the technology meets reality. And it sometimes reaches a situation where people ask themselves whether this technology will ever be usable in a safe manner. But at some point, security researchers and domain experts start to work together on building methodology, on modeling attacks and modeling mitigation techniques, and then we get to a stage of a healthy development of the technology in a safe manner, and it reaches at some point a plateau where all the major threats are already being understood, and the threats and how to mitigate them. And still, new threats are being discovered all the time and new mitigations, but the situation is essentially stable. So we've seen this for web in the 80s, for mobile in the 90s, and now we are seeing this for AI as well. I think in the last couple of years, we're starting to see really the discussion about AI threat landscape more seriously than before. What you see here is a typical machine learning system. There is the training part, where training data is being fed into an algorithm that builds a model. This model can be a classification model, it can be a regression model, it can be many other things. And then this model is used to classify or to predict or to process inputs data. This is called inference. And the result is a prediction or classification. In some cases, in some systems, the result of the model is being fed back is being evaluated in order to continue and improve the algorithm or to make it work for a dynamic environment, for example. Now, when you're looking at the system from an attacker perspective, then if the attacker is inside, or if the attacker was outside but somehow found his way in by malware infection, phishing, whatever, then he can do whatever he likes. The sky's the limit. He can tamper with the model, he can steal the model, he can change every particular decision the model makes. It can replace the model with its own. It can, of course, steal the data. However, even if the attacker does not have a foothold inside and is an outsider, then still there are plenty of things this attacker can still do. Some of them are called evasion or deception or adversarial examples. Most of you probably heard or saw this very concerning examples of how you add a couple of stickers to a traffic sign, to a stop sign, and then the AI engine that within the autonomous vehicle looks at this stop sign and identifies it as a speed limit sign. Very concerning, of course, can have devastating consequences. And from I think all the times where someone tried to make to thwart machine learning model, usually it was not very hard. It was pretty easy to do that because machine learning models, when you build something without thinking of an attacker, and the attacker comes, then probably you won't be safe. We know that from many domains, and AI is not different than that. Training data poisoning, we'll speak in depth about this threat later. Training data leakage is slightly more esoteric threat, but still an important one. In many cases, when you build a model, data from the training data leaks into the model, and this data can sometimes be extracted later on. And whenever you use sensitive data for the training, and usually you use sensitive data for the training, it can be either PII or health records, depending on what exactly the model that you're building, but it will probably be sensitive, and then the threat is real and important to understand and to evaluate and to mitigate. And so how does data poisoning work? On the left side, you can see a linear classifier that is aiming to separate between the red triangles and the blue dots. Now, if you only change the location of a single point, then you get a completely different classifier. It is still effective, but it is different, and really, it is very hard to predict or to restrict the change in the model construction due to the change in a small number of data points. And on the right side, you see even a more deliberate attempt to thwart the model construction. Again, the model here comes to separate between the blue and the red, and the attacker now puts red dots in places that it is clear it will make the model very different than what it was before. And as you can see, the new model now does a pretty lousy job separating the blue from the red, exactly what the attacker wanted to achieve. This data poisoning methodology, terminology, discussion is pretty new. I only met it in the last couple of years. However, the threat itself is not new. It is almost as old as the internet. I think at any time, like myself, when you are looking at a TripAdvisor hotel review, then you're asking yourself, is it a real review? Is it a fake review? Is it the hotel owner now that he's trying to convince me that this hotel is very good, although it is not, or it's a competitor? And the same thing, that TripAdvisor also have the same concern. So the threat of data poisoning is there, and people treat it and treat it. And it is there whenever you have a rating system. It can be e-commerce like Amazon, or it can be travel like Booking or Google or TripAdvisor. It can be even movies like Netflix or IMDb. Whenever you have a rating system and the decision of this rating system is meaningful for someone, then probably someone has motivation to make this system making correct decisions. And then you have the data poisoning threat, and usually people understand that and treat it one way or another. One of the first more popular research fields for data poisoning threat and mitigation is the area of spam filters. Maybe one of the reasons is that this is one of the places where machine learning proved itself effective against cybersecurity threats. And on the left side, you're seeing a model skewing attack on Gmail spam filter. The attackers created many messages and classified and labeled them as benign. And these messages had something in common with messages that they probably planned to send later as spam. So you can think of that as sort of a backdoor within the Gmail spam filter, the backdoor that they wanted to inject. On the right side, you see attackers that took, actually this is a research, not actual attack, but a different approach of availability attack. Here, the victim is a spam-based spam filter, and what the attackers try to do is they knew that the algorithm builds a dictionary of spam hints, and they wanted to pollute this dictionary with a collection of probably very popular words that are used in many legitimate emails. And the attack was pretty successful. With only control of 1% of the data used for the training, the researchers were able to make the model classify 80% of the benign email, of legitimate emails, as spam, and 95% of the legitimate emails as unsure. So probably like myself, you see at the beginning, you see this and you say, okay, so the problem is I give the attacker the possibility to do the labeling. So I'll do the labeling and everything will be all right, right? Wrong. Because in this variant of data poisoning, a clean label attack, the attacker does not have any influence about the labeling process. Here, the attacker wants to attack an image classification system. He wants to convince this model that all these fish that you see in the top images are actually dogs. And the way he obtains that, he takes an image of a dog and he adds an invisible noise that is somehow correlated with the images of the fish. He adds these noises to the image of the dog. And now for us, the image still looks like a dog. For the trusted labeling expert that is working on behalf of the image classification, it also looks still like a dog, and he labels it as a dog. However, the result of this labeling is that the model now will learn that images that have this hidden structure are dogs. And the success of this attack is more than 95% confidence that the model says that the model has when it claims that images of fish are actually dogs. So the threat is there and is real. How to prevent it? There are two approaches that are, again, they were used even before we called data poisoning. You can filter suspicious data, for example, suspicious origins, IP addresses, or users, or suspicious clients. For example, in Booking.com, I think that you can only provide rating if you did actually a transaction. So it gives some level of reliability to all the actors that give ratings. You can also use a fault tolerant data sampling. For example, limit the impact of data points that are arriving from a single entity. And what is exactly entity? Well, that depends, of course, on the problem itself, on the algorithm, the model, and the situation. So these two are pretty effective, but only to some extent. There are also other mechanisms, mostly for detection, like diff tracking, tracking the difference from the previous model, a valid model, and assume that you have data poisoning whenever you see too high distance, or to use a reliable benchmark, a golden data set that you use all the time to make sure that you don't have a model that is completely corrupted. But again, these two are detection, and their effectiveness is very limited. And of course, you can also assume that the attacker does not know what you are exactly doing, or he knows what you're doing, but he doesn't know the model. And to have and that the attacker thus will not know exactly how to attack you, and he will not attack you. But we here in BSides, we know that security by obscurity very rarely proves itself as an effective mitigation technique against any threat, so not recommended, not recommended. So what we have so far, data poisoning is a significant threat on learning mechanism. The threat is critical when using data from untrusted sources, which is typical in almost every place. It is effective in cyber security domains like firewalls, spam filters, and malware detection, and rating systems like e-commerce or travel. And it doesn't have a silver bullet mitigation. It has a collection of mitigation techniques that together can throttle the attacker. Next, we'll go to the, I'll explain about how this data poisoning threat is realized or can be realized in the world of web and API security. So what you see here is a WAF, a web application firewall between applications and outsider threats, aka the internet. Usually WAFs work using a combination of negative security model and positive security model. I will focus on the later one. So positive security model is essentially the idea that everything is bad, except for what we know for sure that is good. So it is sort of anomaly detection. And in order to use that, we need to learn a baseline profile for the web or API traffic and to block or alert on deviation. But when I say that we want to learn a baseline profile, the data that we will use is actually traffic that we've seen through this web API. And if this traffic comes from outside, there you go. We have all the ingredients of a data poisoning attack. So it needs to be treated and mitigated. So web or API traffic profile can essentially look something like what you see here. The red parts here are actually, think of these as carriers of traffic. Can be cookies or query string parameters or body parameters. Each one of them is actually belongs to a host or URL or method or a combination of these, which we call containers. And each one of them has actually a traffic profile. The type of the value that can be for this parameter, whether it can be come several times in the same request or only one time, optional or mandatory, parameter size for numeric values, parameter character set and length for strings, and stuff like that. All of these are things that we will want later to enforce because they have some meaning, some significance for detection of web attacks. It makes a lot of sense to use both the mitigation techniques. First, cleaning, filter suspicious traffic. For example, suspicious events, traffic that was identified as malicious by some other mechanism. Maybe traffic from suspicious IPs that are known to generate malicious traffic. Also, maybe sometimes it makes sense to filter all the traffic during an attack, regardless of whether it came, because it makes sense that the possibility of misclassification here is not negligible. Or traffic for bots, it also makes sense in some cases. The next mitigation is threshold learning. Again, limiting the impact of every entity. Entities that make sense can be IP addresses, user agents, geolocations, identified clients. Also, if you want to avoid learning something that came in a burst of traffic, then you want to learn things only when you see them spread along several hours in a day or several days, depending on your exact model. And eventually, once you complete the learning, you can do the enforcement alert on deviations from this profile. Now, the threshold learning here is pretty easy in batch processing. However, for doing batch processing, you need to consume a significant amount of memory, which is not always practical, and thus there is a need for a streaming-friendly algorithm for threshold learning. And in order to present this string-friendly algorithm, I will take you to a completely different problem and completely different world of a dog food tastiness challenge. We want to know which of the two brands, Pedigree and Theo, is good, is tasty, is favorable by dogs and dog owners. We ran sort of a poll, and Theo got 12 likes out of the 20, and Pedigree got 6 likes. However, we want to do threshold learning here, so we set threshold of at least 3 cities and at least 3 breeds, meaning that we accept that something is tasty only if we've seen testimonies, we've seen indications from people from 3 cities with 3 breeds of dogs, and here only Pedigree passes. And the reason for that is that you can see that, for example, in the red part of the table, you can see that San Bernard owners and none of them said that Theo is good, and people from San Francisco also never said that Theo is good. But for Pedigree, we have a pretty balanced voting spread between the different cities and the different breeds. And one of the reasons for that is that we had, you can see many voters that have Pomeranians and many voters from New York, and all the 6 people that are New Yorkers with Pomeranians, all of them liked Theo, but we didn't want to count them all as new ones, but we want to count them somehow together, and this is exactly what we wanted to achieve. So how to implement this? So we think of Pedigree as an object, and of the tastiness as a fact, a Boolean fact. It can be tasty or not tasty. And the threshold learning is focused on 2 attributes, city and breed. Each of them has threshold of 3. And for each one of them, we keep a set of all the cities we've seen so far. At the beginning, we've seen no data, so we know nothing. So everything is turned off. For Theo, we have the same, and we can have another fact, whether the dog food is nutritious or not. Data comes in, and now we feed the data into the system, and we see that now the sets for cities and breeds for Pedigree tastiness are, we have a set of 3, and thus we passed the 2 tests, and we're good. We believe that Pedigree is tasty. However, for Theo, we have only 2 cities, and we have only 2 breeds, and it didn't pass any of the tests, and therefore Theo is not accepted as tasty. So looking at that, so what we did, actually, we learned the Boolean fact that an object X has a property Y. Looking at that from a memory consumption perspective, then the memory consumption is proportional to the number of objects, the number of properties, facts, the number of attributes, and the threshold. However, it is independent of the size of the data, which is exactly what we wanted to achieve. How to use Boolean facts for Web API profile? Well, it is pretty straightforward. During the training, then for every request we see, then we extract for every fact that is interesting for us, we can extract a flag fact X seen. And then we'll take all these fact X seen flags, and we'll collect them together, see which thresholds are passed, and then we'll get into the profile fact X allowed, in case we passed fact X passed all the tests, and if not, we'll have fact X prohibited. During the inference, we have a profile, and now for every new request, we can extract all the fact X seen from this request, and if we have a fact X seen that is also prohibited, then we have a violation, and this is what we wanted to achieve in the first place. So we can learn Boolean facts, and we can use them very effectively for the web profile. And the next question is, what can you do with Boolean facts? It seems like a pretty limited model. And in the next couple of slides, I hope to convince you that this model is not limited at all, actually, that it can obtain quite a lot. So let's start with what I call objects or containers. We want to learn what are the hosts, the methods, and the query string parameters and the relations to hosts and methods. So actually, this part is pretty much straightforward because all the things that we want to learn actually have a Boolean nature. URL X at host Y, this is one Boolean fact, allowed. Cookie X at URL Y, allowed. Query string X at URL Y with method Z, allowed. All of them are Boolean facts, and again, this is pretty easy. It works very well, no problem here. However, what about the parameter traffic profile? We have data types, we have ranges, character set, regular expressions. Can we also deal with these guys? So I will dive into the area of parameter type. So suppose we have a parameter and we want to classify, to include in the profile the type of this parameter. Now we will have a num is a numeric type allowed flag, and which we'll try to learn. And if we will not learn it, then we will have a different flag in the profile, numeric type prohibited. We will also have a non-numeric type allowed and non-numeric type prohibited. In the next slide, I will show how exactly these are used. They are very important. We have the same for string, for Boolean, and also for none, which represent a situation where we don't have a value for this parameter, which is also, of course, an important thing to learn. So suppose that we want to include in the profile that the type is a string, and then we learn the flag str type allowed, okay? But we are not learning the flag num type allowed because we didn't see num type, or maybe we've seen num type, but we didn't see it in a way that passes all the threshold tests. We also we didn't see non-str type too much, so we don't allow non-strs within the profile, only strings. Now, if we see x equals abc or x equals x@gmail.com, then these are strings, we're good. If we see x equals 23, then actually we have num type seen, and it contradicts the num type prohibited, and there we go, violation. Another example, this time using regular expression, we want to enforce the fact that type is a mail address. I hope that you understand now that the more important is the prohibited part and not the learned part. And we learned that non-mail regex is prohibited. And the reason is that we didn't see many indications of non-mail values in the traffic for this parameter. And therefore it is not allowed, and therefore it is prohibited. And now, whenever we see x@gmail.com, then this is okay, because the non-mail regex seen is not there. However, if we see ABC, then the non-mail regex seen is there, and it contradicts the non-mail regex prohibited, and again, we have a violation. When it comes to mandatory parameters or optional parameters, then missing prohibited and missing allowed are the flags, the facts that we are using, and it is essentially very similar to what we've seen with the strings. When a parameter we want to represent the fact that it shall have no value or that it has multiplicity, then again we play with a non-none type and multi-occurrences facts. When we want to talk about a character set, then non-B64 character set fact. When we want to play with particular special characters, and we say that ASCII 21 is allowed or prohibited, ASCII 7E is allowed or prohibited, etc. And when we want to deal with ranges, then here we need a little trick to do discretization of all of these ranges. Then we will not know exactly that the parameter is between 34 and 345, but it will have to, we'll split the domain into ranges. For example, we have greater than 5,000, greater than 500, lower than 10, and we can play with these facts in order to represent these ranges in a way that makes sense for the web security domain and attacks. So let me summarize. Data poisoning is a significant threat on learning mechanisms, especially when they rely on data from outside, with or without labeling outside. And it is applicable whenever this threat is there, whenever you are doing something meaningful and that someone cares about, which I hope for you that this is always the case for you. Threshold-based learning may provide an adequate, robust learning solution. The Boolean facts framework provides a streaming-friendly implementation for threshold-based learning of a profile. And although the Boolean facts framework at the beginning looks restricted, in fact, many features can be expressed through this framework. Thank you very much. And now we have time for a couple of questions.
All right, so we are back now after our presentation, AI in a Minefield, Learning from Poison Data. And as I mentioned before the presentation, we have Jonathan Azaria here with us today to help answer questions about the presentation. And so I'm going to look into Slack at questions. And are you ready, Jonathan?
Yes.
Sweet. Then let us get rolling. So one of the questions that is there is, so when would I allow training data in a system? Why would I allow training data into a system where I can't control that data? So why would I allow others to contribute to training my data? That seems really counterintuitive if you want to have a good data set.
Yeah, so that's true, but that really depends on the kind of data and on the budget you have. So if we just take a very simple example of a machine learning model that tries to classify dogs, for example, so any other kind of images. So what you'd have to do is that you'd have to have some people looking at a bunch of images and saying this is a dog, this isn't a dog, and that just costs a lot of money to have so many people do that. So what a lot of people will do is that they'll try to look online for some sort of source of images of dogs, or just type dog in some search engine or do something like that. And in this case, they might end up using data. First of all, that's data from an untrusted source, and they might end up using data that isn't good, poison data of some sort. And that's the first option. The second option is one we talked about in the presentation, is if you need to use some sort of a crowdsource. So for example, if you want to get reviews from users. So that's by definition an untrusted source. You don't know these different users. And you can try to mitigate that by saying that only verified users can review, or users that you have verified that they purchased this product. But that's still an unverified source, a source that you cannot completely trust.
Okay. So then in this case, there may be cases where you have to rely on external sources.
Yes.
Okay. Yeah, that makes sense. And that kind of leads into another question. So if you have to rely on these external sources, and some of the controls that you mentioned in the presentation are basically limiting the inputs. So limiting the number of inputs that an individual who's logged in can make, or limiting the number of inputs from a source like an IP address or a location code or something like this.
Mm-hmm.
And so my question is, how viable would it be for some sort of criminal organization to set up a distributed data poisoning service? Do you think that would be a lucrative kind of service for an attacker? Yeah, so have you seen anything like this, or is this a service that would be interesting, I think, for a criminal organization to set up?
Okay, so that's a great question. We actually mentioned something similar when we talked about spam. So there was this case where a group of spammers did try to have a mass. They tried to fool Google's spam detectors, so they submitted a lot of spam reports that they try to whitelist their spam. So that is a problem, and it is something attackers can do. But the big question is, how much will that cost them? So if we go back to the previous example of reviews, okay, if someone is supposed to review a certain product, so if you limit it to verified users that have purchased this product, attackers can still fool the system. They can still have a lot of fake users buy these products and then review it, but that's just going to cost them a lot of money. And if the whole issue here is that if you limit the impact of one user or one entity, they'll have to use multiple entities, and that can just cost them a lot of money. If we go back to the example of API security, so if the site has millions of entries or millions of users, the attackers will have to somehow create more or less a similar amount of users in order to influence the model. So that might just cost them a lot of money up to a point, where it's just not worth it.
Yeah. So that may be something that you keep in the back of your mind when you're designing this kind of system. What would the cost be in order for an attacker to be able to mount this sort of attack? That's an interesting way to think about the problem. There is, so we are a little bit over, but I'm going to ask this question anyway. How would you approach keeping a model up to date to always match valid, allowed, intended traffic for the continuously changing app behind it? Because we're living in an agile world and things are always changing. So yeah, that's the question.
Yeah. So that is a good question. And usually when you do API security, you have to somehow know what the app looks like. So you need to have a Swagger file of some source, or you need the customer to manually update the different endpoints in the API. You might have your own service that does discovery, but you need to somehow do that. That is a good point, and you need to just try and add filters that somehow mitigate that. So you need to look at changes over time. You need to try and find, let's say, parameters that have shifted. So there's this point in time between, let's say, having the old parameter and then have this new parameter. If, let's say, a parameter changed from, for example, a number to a string, so you will have a point in time where you won't be able to learn this difference, and you need to come up with some sort of a solution. That is, it's a big question, and you just need to figure out how to do that. One example can just be using some sort of a tolerance. So you don't immediately block attacks, or maybe don't block attacks if they don't completely violate. So if you have a number and now you just have a number with some alphanumeric characters, you might not want to block that. If you see special characters, you might do, but you need to come up with some sort of a solution that knows how to bridge the gap between these two.
Holy cow. So that question just made my head kind of explode with ideas of what could potentially go wrong with an AI system. So thank you for that comprehensive answer. And we are out of time, so we need to take a few minutes break. So thank you so much for your time today, Jonathan, and coming by and answering questions for this presentation. Folks, we will be back in a few minutes. So take some time, go and hit our sponsor Slack channels. They're giving away goodies, so check it out and see what's there. Once again, thank you, Jonathan, for being here, and we will see you all soon. Bye-bye.
Hello, everyone, and welcome back from the slightly short break, I guess. We had a slight mix-up in the schedule, so the following talk will be 5 minutes later than given on the homepage, but yeah, I don't think this will be an issue. Yeah, jumping right into it. My name is Oliver. I will be the moderator for the next two talks, and with me here now are Sarit and Ophir, also from Imperva. They will be holding the next talk about the operations of the Kashmir Black botnet. I'm really looking forward to the talk, but first of all, welcome Sarit and Ophir. How are you doing today?
Hi, we're good. All's good.
Very good. Perfect. Do you want to give us? Yeah, we're very glad to have you. I'm great that you give the talk for the conference. Do you want to give a short introduction before we skip to the real talk?
Yeah, yes. Sure. Yeah. So we hear about botnets all the time. And in this session, we'll give you a deep dive into one of them. It's called the Kashmir Black botnet. I will start by talking about botnets in general and describe the Kashmir Black and its entities. And then we will present the operation and talk about the DevOps behind it. That's it. I think we can start.
Perfect. Yeah. Thank you very much. So everyone have fun with the talks and see you afterwards for the QA.
Sure. Hi, everyone. Today we're going to talk about the crime ops of the Kashmir Black botnet. But first, let me introduce myself. My name is Sarit, and I'm a security researcher at Imperva for the last 10 years. I mainly focus in web application security, and I develop algorithms to detect and protect against attacks. My colleague Ophir is a security researcher for the last 5 years. His focus is in database and web application security. Before diving into the bits and bytes of our research, I would like to introduce you with the Kashmir Black botnet. So, it all started on November 2019 and lasts 11 months, which is basically a research period of time. We discover a botnet that attacks popular CMS platforms, such as WordPress, Joomla, Magento, etc., in more than 30 different countries around the world. It performs millions of attacks per day on average, and we calculated that there were hundreds of thousands of bots out there participated in the botnet operation. The bots utilized dozens of known vulnerabilities with different attack types, like file upload, remote code execution, and many more. This session is a journey into the botnet core from the attacker point of view. So let's start. Security research investigation can sometimes be like a crime scene investigation, but our crime scene is spread all over the network with nobody in place. So we need to collect the clues and fingerprints to construct a picture of the virtual crime. As part of a study carried out at Imperva, we observed around 9 million attack attempts exploiting PHP unit remote code execution. And we were wondering, why is this CVE so popular among attackers? To understand this hype, we started to analyze attacks from our data lake. We saw different IPs using the same payload over and over again, attacking different customers, which remind us a botnet behavior. So we decided to download the payload and dive in. And we basically started the mapping step. We downloaded the code and performed analysis. We revealed all the entities of the operation, and later I will talk about them in further detail. The next step we took was infiltrate. We saw that the botnet is updating on a regular basis, and we decided to act like a bot and gather these updates for later analysis. And finally, we played a victim. We created a honeypot in order to understand the post-exploitation stage. So let's review all those entities that play a role in this massive operation. When looking at the botnet entities, we can split them into 3 groups: the botnet infrastructure, the botnet third-party services, and the botnet actors. Inside the botnet infrastructure, we have the CNC and repositories A and B. Under the third-party services, we have GitHub, Pastebin, and Dropbox that the attacker used in one hand to camouflage his operation, and on the other hand to make the botnet more flexible. Under the botnet actors, we have the victim and 2 types of bots, pending and spreading, and I will describe the difference between them later in the presentation. The first entity in the botnet infrastructure, which is responsible for the entire operation, is the command control. And here we can see the login screen of the CNC. The Kashmir Black CNC is located in Indonesia and has 3 main roles. It supplies attack instructions to bots. It receives attack reports from bots. And it supplies a malicious script that infects the victim server. Here we can see a snapshot of the infection script. The attacker defines a parameter that represents a cron top task. And the task contains a Python script and scheduled to run every 3 minutes. It includes several imports and uses base64 encoding to obfuscate its malicious payload. We can also see that the output of this task will be sent to DevNull, so no history will be saved. In the next code block, the attacker redefines the victim's cron task to include the malicious Python task that we just saw in the previous section. And as part of this redefinition, the attacker makes sure to remove all mail notifications. Let's move to the repositories. The original repository A, as you can see, is a printer component shopping site. It was hacked by the attacker and was used to store the communication script file to communicate with the CNC. Another type of repository entity in the botnet is repository B, which is a site that was classified as an educational institute and was used by the attacker to store bundles of exploit and payloads. Here is an example of the exploit and payload bundles. The attacker files are located under the CSS path, among other CSS files used by this innocent web server. We can see that the name of the bundle files start with the in-memory prefix, and they are actually zip files hidden with the CSS extension. And here is their modification date. One of the best qualities in this botnet is that the infrastructure is just like plug and play. The attacker can expand his target victims by adding new payloads just by uploading them here under the CSS directory. No infrastructure changes are required, and every file represents an exploit that targets a specific vulnerability. Here is a partial list of CVEs the botnet uses as part of its operation. Among them, we can see remote code execution, file upload, remote file include, and many more. And these vulnerabilities are related to different plugins, widgets, and themes. And we can say that the conclusion here is that it's not necessary to use exotic exploits, in order to expand the botnet. Moving to the cloud-based services. Another type of entity used by this attacker is GitHub. It was used as a version control to store some of its files. And when we checked the repository, we saw P3 web shells and crypto miners. And we can say that by using GitHub, the botnet achieves a layer of flexibility. The attacker can easily update a file in this repository without interfering with the botnet activity. Another entity is Pastebin, which is a website that allows anonymous users to share plain text through public posts that they call pastes. The attacker used this paste as a quick and easy way to access and download backdoors through the infection step in the botnet operation. And later we will show how Dropbox was used in order to upgrade the botnet, hide the operation behind legit cloud services, and also to secure the CNC. Now, let's talk about the 2 types of bots. First, the spreading bot. This bot constantly communicates with the CNC to receive attack instructions. Those are commands from the CNC telling him who to attack and how. This bot is being used to infect new machines and expand the botnet. A victim that was infected by the spreading bot can become one of 2, a spreading bot or a pending bot. Now, let's talk about the pending bot. As I said before, this bot is a victim site that was infected by a spreading bot, the one that appears here. And as a result, is under the control of the CNC. It stays in idle mode until the CNC approaches and changes purpose. And this is actually why we named it pending bot. And I will talk about the purpose in a bit. And the difference between these two is that the pending bot does not initiate communication with the CNC. Moving to the Cashmere Black botnet scope, the infiltrate step. The best way to learn of organization is to be part of it. Same for learning about a botnet operation. We call it the infiltrate step. Once we mapped all the entities of the botnet, we wanted to understand the scope of the botnet, its victims, the attacks, and the evolution. And to answer those questions, we had to take a more active approach to the investigation. We learned a communication protocol between the bot and the CNC, and we mimicked it. We infiltrated the botnet by constant communication with the CNC. We went undercover and impersonated a spreading bot in the botnet. And without actually attacking any targets, we started to collect information about the botnet victims. We can see in the picture an example of attack instruction in JSON format received from the CNC. The first parameter, the script, contains the commands that will be executed by the spreading bot. First, it will run the curl command to download the expo and payload bundle that will be used to infect the victim. And here is the name of the file to download. We can see it's located under the CSS directory in repository B, the one I just showed you. The second parameter, the payload, contains a list of victim sites that will be attacked by the spreading bot. And the last parameter is the host name, or the IP that hosts all those victim sites. Moving to the botnet purpose. In order to understand the purpose of those victims as pending bots, we had to become a victim ourselves. So we created a CMS honeypot and attacked it with our spreading bot from the infiltration step. Then we reported back to the CNC of a successful attack, and by that, our honeypot became a pending bot in the Cashmere Black botnet, waiting for the CNC to approach. We saw 5 types of purposes for the botnet. About the first two, we already discussed. Those are the pending bot and the spreading bot. So we'll talk about the others. An exciting purpose we observed is the crypto miner that mines Monero coins. As part of the code analysis we did, we got access to the hacker's payment address, and we could see his balance in real time. The next purpose was discovered as a result of our CMS honeypot that was converted into a clickbait bot. When we tried to access the honeypot's login page, we were redirected to one of many clickbait sites. And the last purpose is defacement. Once we saw the defacement signature, we discovered the nickname of the hacker behind the botnet. We also discovered that he is part of the Indonesian hacker crew Phantom Ghost. Searching the internet, we found out even more interesting information about the crew, like their Facebook page and even an online shop that sells the Phantom Ghost crew t-shirts. Now, after we're familiar with all the entities, Ophir will continue and show the entire operation in live.
Thank you, Sarit, and hi everyone. So, how this botnet works? It all starts when a bot exploits PHP unit remote code execution on a victim server. It causes the victim server to download the infection script from the CNC and execute it. Now, the infected server will approach repository A every 3 minutes to download a fresh communication script. In this stage, we can say that the victim server is part of the Cashmere Black botnet. The newly infected bot communicates with the CNC to get attack instructions that describe who to attack and which bundle to use. Then the bot downloads the bundle from repository B and additional payloads from GitHub and PasteB. Then the bot attacks the victim, and on successful attack, it will become part of the botnet. As a last step in the process, the bot reports back to the CNC. Now that we are familiar with the operation, we can move on and describe the evolution of the botnet over the research period and the DevOps strategy that enabled it to carry out its crimes. Remember that the botnet had only one repository for A and B? Once the botnet size increased, so did the load on the repositories. In addition, since the repositories were actually legitimate sites, they couldn't be considered as permanent and reliable entities. The attacker had to take action. 3 changes were implemented in the botnet infrastructure to solve this: adding new entity, repository A load balancer, expand repository A into multiple repositories, and expand repository B. There were 3 main reasons behind these changes: to make the botnet more dynamic and scalable, add redundancy, and load balancing. The following diagram shows the old infrastructure against the new one. While in the old infrastructure, every bot will address directly repository A, in the new one, each bot will address the load balancer to get one of many repositories. To integrate this change into the botnet operation, an additional change in the botnet was required. We will discuss this change later on. Now, let's talk about internal changes that were made in order to secure the CNC and the botnet operation. The CNC is the most sensitive and critical component in the entire operation. Securing it is critical. Let me take you back a little bit to the steps where we infiltrated the botnet and played the victim. We created a honeypot. We attacked it with our spreading bot and reported back to the CNC. We believe that the attacker grew suspicious as he performed 2 internal changes in order to avoid interfering with the CNC. The reporting address was changed and bot IP tracking mechanism was added. First change is related to the reporting address. This change helps with managing bots versions. Bot that report to the new address is a new bot. Second change is within the botnet's communication script. It was updated with a bot tracking mechanism. A simple architecture change adds the bot's IP and country while it communicates with the CNC. It allowed the CNC to track and monitor the operation of each bot in the botnet. There are 2 goals behind this mechanism. The first is to secure the botnet, and the second is to manage bots versions and upgrades. Now, let's see how it comes to work. The changes that we described created a situation where some bots were using the new infrastructure, while others were only aware of the old one. This diagram describes the upgrade process. On the left side, you can see the old infrastructure. When an old bot communicates with the CNC without the IP tracking header, the CNC in return sends back attack instruction that will instruct the bot to download the upgrade script from repository B. Once the bot will execute the script, it will turn into a new bot that is now aware of the new infrastructure. On the right side, the upgraded bot addressed the load balancer to choose one of many repositories. Now, let's talk about migrating the CNC to a cloud-based service. There are fundamental problems in the botnet architecture. Since bots communicating directly with the CNC and the repositories, their IP is exposed and security controls may block them. An interesting infrastructure change has evolved to solve this problem, integrating Dropbox into the operation. instead of communicating directly with the infrastructure entities, the CNC and the repositories, the bots are now communicating only with Dropbox. Now, Dropbox API is being used to fetch attack instructions and upload reports. This is a big step towards camouflaging the botnet traffic, securing the CNC operation, and most importantly, making it difficult to trace back to the hacker behind the operation. Now, let's discuss some key takeaways. Botnet deployment is similar to application development process. There are some important key features we need to consider in order to create a stable botnet that is here to stay. Those are stability, flexibility, and CI/CD. In order to create a stable botnet, we need to take into consideration load balancing and redundancy, enabling scalability while growing. In other words, stability is the foundation that enables the botnet to exist. But this is not enough. The separation of the exploits from the infrastructure enables maximum flexibility, as the attacker can add new exploits anytime. Together, those two key features are the basics of the ability to grow and expand. On the other hand, we have the CI/CD branch that enables the version control, that includes version control and deployment cycles. We call it automation. Behind every massive operation, we must have an automatic process to support it. Expansion and growth cannot exist without a solid CI/CD process. Now, let's talk about the insider point of view. As a security company, we have data of hundreds of thousands of customers, where we can see attack in the wild. But this is not good enough, since our data is biased by our customers. Here are a couple of advantages we got from the insider point of view. So, being inside the botnet operation gave us an advantage in the analysis, as we could see the big picture and not just a small portion of the infection. We watched the botnet operation and evolution from the first roll. We saw new repositories, exploits, and payloads added in real time. By analyzing the code changes, we concluded what motivated the attacker to perform such changes. We had a unique foothold that enabled us to analyze the victims from the attack instructions, extracting country, platform, domains, etc. The inside intelligence led us to the educated assumption that there is kind of an automated mechanism that searches for potential vulnerable targets and initiate them in the queue in the CNC. Analyzing the exploit distribution explain which exploits are in use and the distribution of usage. What is the frequency that they are being used and which are more common than others. All of this information is accessible only from the insider point of view, and it is critical in order to understand the scope of the operation, the motivation and challenges of the attacker. Now, let's sum everything that we talked about. In a botnet development, the attacker wearing multiple hats. The attacker is the developer, the architect, and the DevOps. A usage of third-party services are critical part of the infrastructure in terms of camouflaging the botnet and bypass security controls. And it is not necessary to use exotic exploits in order to expand. So what can we do to prevent infection? First, make sure that you are up to date with the latest security patches and that there are no unused or unsupported plugins installed that might increase your attack surface. In terms of research, first we need to map all the entities. We need to learn the botnet communication protocol, and last, visibility is essential to understand the big picture. You are probably wondering what is the current state of the Kashmir Black botnet. So, when we decided that our research has come to an end, We collected IPs, host names, hosting services, and every possible piece of information, from bots, repositories, CNC, and entities. We notified the owners of the infected servers and hosting services about the malicious activity, and today, the Kashmir Black botnet is dead, at least as we know it. We checked our data lake and we couldn't find any traces of new infections. Thank you very much for listening to our talk about the Kashmir Black botnet. Feel free to contact us if you have any questions. For additional information, you can read the 2 blogs that we wrote. Just search for Kashmir Black botnet on Imperva's site. Thank you.
Thank you.
So, thank you very much for this great talk. It was super interesting, very technical information, which I personally like a lot. So we do have some questions already in the Slack, I think more than we can answer in the time we have now, but let's just get started. The first one would be looking at like the current prevalence of ransomware that's all over the media. What would you say is the current situation about botnets? So what role do they play at the moment?
So I think that there are a lot of kinds of botnets, some infecting Windows, Linux, IoT devices. We see a lot of crypto miners botnets that performing DDoS attacks or phishing campaigns. So it's really all over the place. And I think that also we saw specifically in the data security area in our honeypots, database honeypots, also ransom botnets that performing ransom to steal the data. So crypto, I think, is the most, at least from what we see. But you know, the world is very big, and there are a lot. We are not monitoring everything, but definitely there are a lot of types. By the way, there are also botnets for rent. We saw this as well. Hackers that take over a lot of servers and just offering them to you. You can rent a botnet and decide what you want to do with it. So really, there are a lot of types. And
yeah. So basically everything you can make money with. I mean, this is the case in that scene, of course. I think it's also a great segue to the next question from Henning. He was asking about the economics, like who is actually hunting down botnets at the moment? Is it mainly academia? And who pays actually for people that try to investigate more and get more insights on how the botnets operate and who is behind them?
Do you want to take it?
If you have an answer, I don't actually have an answer to who pays for those botnet hunters. I think security researchers in some way, or maybe maybe there are divisions that protect, like cyber protection and something like that. They try to find those botnets. They're the group of IPs that perform some attack on a specific industry or something, or several sites.
Yeah, I think so. I think that it's more like how we were able to identify this botnet. It was just you know, we saw it in our data and we started digging. I don't know if probably there are people that hunting down botnets. I don't know who pay for them, but you know, there are a lot of reasons also in the security market. It can be for, I don't know, if you want to write something or create an article, or maybe, I don't know, create new startup that do stuff.
Cool. Yeah, one final question. would be related to you talked about the journey that you had, like the different phases of your infiltration. What was your emotional journey? So I know it like from a pen test, when you find a nice vulnerability, you get very excited. How was it for you when you did the infiltration and your honeypot was hit?
Actually, it was very exciting. It was like most of the time you're in the darkness, you don't see the entire picture of everything. You don't see the entire attack. And here we were able to see from inside from the hacker view, from the hacker point of view. We saw how it is evolving and how new exploits were added. And we were like, every time we saw something new, we were like, what he's doing with that, why he added it. And so it was really great it was like a cat and mouse, like every time we saw something that he added and we want to see what's the purpose of it. And then he added another thing. It was like ongoing process. We saw new entities added all the time and how it's like Ophir said, that he added a load balancer and all that stuff to make the botnet stable, and being able to process a lot of incoming messages from all the botnets that he added to his botnet. Like, yeah, it was really great. So it's actually, we hear about botnets all the time, but being inside and see it from the other point, it's great. Yeah.
Cool. Very cool indeed. Sounds like material for a movie, actually. So maybe. But there's also a link to your blog article if someone wants to read more into it. So please go on the Slack channel of the talk. Also, there are additional questions we unfortunately don't have time to answer now, but it would be great if you can look at them and
Sure.
yeah, answer them on the channel. Now I can say thanks again for this very great talk, Sarit and Ophir. It was wonderful having you. Thank you for your time, and see you on the Slack and hopefully at next year's conference. So great stuff.
Thank you. Bye.
Thank you. So, welcome back. We have with us now Sajal Thomas, actually from Munich. So welcome and great to have you here. Sajal is talking about another offensive tactic or offensive topic about the modern adversary tradecraft. So yeah, thanks for having you. How are you doing today, Sajal?
I'm doing very well, Oliver. How are you?
Oh yeah, I'm doing good as well. Pretty nice weather outside, but still I'm enjoying the conference very much. So I would say we'll start with the talk right away. I recommend that you all go to the Slack channel, ask questions as they come. Sajal will be there on the channel, I guess, to answer them in live. And we will also have time for a quick and nice Q&A sessions after the talk. So let's start right into it.
Greetings, everyone. Welcome to my talk. I hope you're all safe and doing well. First of all, thanks a lot to Morten and Jen and the rest of the LBsides crew and the BSides Munich crew for organizing this. Massive props to all of you. Right, so let's get right into it. Modern adversary tradecraft. But first, a bit of an introduction. Who am I? I'm Sajal Thomas. I work at Siemens. I'm doing adversary simulation and offensive security over there. I was previously at FireEye, and I'm a first-time B-side speaker, so yay to me. And a quick one-liner to describe me is that my head is red, but my heart is blue, which means that I'm a red teamer by profession, and my mentality is that of an attacker, but in the end, I want the good of defense. I'm a defender by heart, and I really work to make the lives of defenders easier. Okay, straight to the point. Headlines about ransomware that we've seen in the past few months, the past few years for that matter. Insane timelines, 1 hour, 5 hours, 2 hours. Absolutely incredible timelines for incident responders to even think about deterring or detecting or responding to these threats. Ryuk, from phishing email to domain-wide ransomware in 5 hours. Networker, RDP to a box, dumped creds, RDP into domain controller, and ransom every computer, less than an hour. So yeah, this is what we're dealing with, and this is what we're going to talk about in a sense. Not ransomware, but mostly about what we can do about a threat like this, an unprecedented threat, and a nuisance more than anything else. Right, so quick 20-minute adventure. Let's go in and out and get right into it. So what this talk is about, so we're here to talk about the adversary tactics, techniques, and procedures. Then we want to explore the overlap in the TTPs between threat actors which have different motivations. So we want to see if ransomware groups, the kind of ridiculous timelines that they operate in, does that mean that they're extremely sophisticated, or does that mean that their malware is super complex or extremely difficult to reverse engineer, or what those things mean, and where there's a little bit of an overlap in these techniques between cyber espionage groups and ransomware actors. And in the end, of course, we'll talk about some detection and response strategies that can help the defenders out there to deal with the threats that we face today. Okay, so those of you unfamiliar with the term might be wondering what tradecraft actually is. It isn't all spy stuff. Of course, the origins of the word do come from the Cold War, and tradecraft, at least in the intelligence community, it refers to the techniques and the methods that are used in spying. But today, it's the term itself is used for just describing the skills and methods that are used for any job, for that matter. So for us, what that means is adversary tradecraft means the methods that our adversaries are using. But you might ask, who is my adversary? Maybe that completely depends, but in all likelihood, it's probably not Russian or Chinese intelligence, contrary to what mainstream media would want you to believe. But it most likely might be criminals and ransomware groups. So let's say, for example, if you're just selling Weisswurst at the corner shop, you probably don't have to worry about Russian or Chinese intelligence. However, you do have to worry about criminals or ransomware groups trying to ransom your computers and extort your data and ask you for money. But yeah, who cares? Why does it matter? Well, It matters because it depends what your adversary, who your adversary is and how they behave. And the reason I have this picture is it's just an amazing picture. This is one of the members of the ransomware crew. And of course, he operates out of Russia based on various indictments by various governments. And yeah, he is one of your adversary if ransomware groups are your adversary. And one of the videos that I really like that describes this adversary is this one. I love that video. I don't know if you quite got the audio, but yeah, that was a pretty good that was a pretty good drift and a burnout. But yeah, why does it matter? It matters because, well, ransomware groups operate differently. They're more noisy, and not noisy in the context of having super fast cars, but more noisy in the sense of the kind of activity that they perform in your network once they're in, the kind of techniques they use, the kind of approach they have to going about their operations. All of these things matter when you're responding to such adversaries. So you need to be able to profile your adversary and say that if this is a noisy adversary or if this is a ransomware group, then the possible outcome in the near future, like or in the next few hours, is going to be a full lockout of our computers. Anyway, so the ransomware groups, of course, are more noisy. They're more they like to just break in, grab what they can get, exfiltrate it, and then ransom the entire network. And of course, then come back to you with a ransom note and say that just transfer some cryptocurrency to this account. And yeah, you either you comply or you don't. But there's a huge gulf in the sophistication between ransomware groups and state-sponsored espionage groups, because espionage groups, of course, operate much differently. They're much more stealthy. They do not want to make noise. They want to remain low and slow. And of course, for them, the job doesn't end. They need to stay where they are. They need to continue seeking the information that they seek, and they have to do it very quietly. And we're going to talk about the low and slow parts specifically in the next few slides, because that's where it gets interesting. Right. But there are plenty of overlaps between groups, even though their motivations are completely different and their approaches to going about their objectives are completely different. This is a meme that I shamelessly stole from one of my former colleagues, Bryce. And more often than not, this is the case, that any loader or any sample that is found on VirusTotal, or if you're responding to a breach and you see that there's a custom loader that's doing something fancy, ultimately it is loading Cobalt Strike. And for those of you unfamiliar with Cobalt Strike, it's just a framework that penetration testers and adversary simulation professionals like myself use, because well, it's a great platform to begin with, and it gets the job done. But the point here is that it is now being used by groups with varying motivations and varying tactics. So it's really hard to identify once you get to the point of triaging the shellcode, and when you see that, okay, this shellcode is this is Cobalt Strike, this is definitely Cobalt Strike. It's hard to distinguish who the threat actor is, because it could be your red team, or it could be your It could be a nation-state espionage group or a ransomware actor. So it's hard to draw those distinguishing lines when you're triaging these threats, but we're seeing that even though the approaches are different, there's still a lot of overlap between the various threat actors out there, and we're now seeing things like code-signed executables are now very, very easily found in just about everywhere. Criminals can just buy these code signing certificates off the dark web for $300, $500. Sometimes it's a little more if you want to bypass smart screen. I think it's about $1,500 or so, and yeah, it's worth the investment, because ultimately you're going to ransom a huge organization, and the money makes up for itself. So code signed executables or code signed malware is definitely something that's much more common now, and the stage 1 or the stage 2 in the malware, which is code that's loaded eventually or further down the line, is turning out to be cobalt striking practically, well, every other breach or every other threat intel report that you read, every other ransomware analysis blog, or it's all over. And of course, the most interesting is the post-exploitation tools that we're seeing. We're seeing a lot of nation-state adversaries, as well as ransomware groups use Mimikatz and Bloodhound and Responder, and there's quite a few. But the point here is that even though these tools are open source, they're extremely well known by the security industry. They're heavily signatured, but they're still very, very popular because all it takes is a few customizations, and you don't have to reinvent the wheel. And that's the interesting part about the adversary tradecraft. It's that the threat actors are not, they're finding that it's much easier to just use that's already out there instead of creating a tool from scratch. So let's say that a threat actor wants to dump credentials. Now they have the capability to write something that's exactly like Mimikatz, but it's not Mimikatz. But they would just rather not, because this has very, very obvious benefits. Well, it saves time and effort, of course. This means you don't have to hire developers. You don't have to spend countless hours in building the malware. And well, 2, it's very widely used. It's tested in production. Every red teamers and pen testers have already used it. If they've seen issues, they've opened GitHub issues on GitHub or feature requests. And of course, the main benefit is that it muddies the attribution waters. So you can never profile a threat actor by the tools that they use. So to put it simply, if I wanted to create, or if I wanted to be a threat group of myself, and if I started building all these tools myself, which were completely custom from scratch, then I could only use them in one mission, because once they profile, they're burned, and if I use them again, then it points directly to me. So there are some very obvious benefits of using open source tooling. Of course, I have no problem with open source tooling per se, but that's a different topic that I'm not getting into. Right, so getting into the tactics, techniques, and procedures itself, the important point here is that every adversary has to, at some point, perform a certain set of actions in order to complete their mission. So this means that once the adversary is inside your network, they need to perform the same steps in one way or another. Maybe they do it differently, maybe the tools they use are different, maybe one threat actor uses tool A, the other uses tool B. So let's say maybe a ransomware group uses PSExec for lateral movement, but maybe a cyber espionage group uses WinRM, but they still need to do that. They still need to perform that action to move laterally. And this is where a detection opportunity arises, and every single command that is executed, every network packet that's sent, every step forward that an attacker takes in this kill chain, as they call it, which is quite popular nowadays, each of these steps is a detection opportunity at the end of the day. And as a defender, it's our job to think of each of these steps as a way to catch the adversary. It doesn't matter if you don't stop them in the very first opportunity, you get a second opportunity, a third opportunity, a fourth opportunity. There are always opportunities because the attacker has to perform those steps. If they want to steal the data, they have to move laterally to where that information is. If they want to ransom your entire network, they have to compromise the domain. They need domain admin so that they can spread across the entire network. So let's get into some popular case studies. Would be remiss if I didn't mention SolarWinds here because it's the most recent, one of the most talked about. I mean, a lot has happened since SolarWinds. I mean, Microsoft Exchange happened, and then Pulse Secure happened, and SonicWall happened, and yeah. Anyway, so SolarWinds was, of course, the more sophisticated case study in our case. We saw that the threat actor was actively reading the process space of MS build processes that were running on the build server. And on the right, you can see the screenshot that's from the CrowdStrike report, which still has some comments that were left in, and we can see that the hash of msbuild.exe, the name of the process, was used to compare it with the processes that were running, and then the threat actor also looked into the PEB of the process, and the PEB is where all the good stuff is stored of a process. So that's where the command line arguments are stored. That's where the attributes of the process are. So the threat actor actually went to the extent of reading the PEB of the MS build process after finding it, and then comparing the command line arguments and finding and replacing whatever they saw on the command line arguments, in the sense that if they saw that it was running a specific, it was building a specific project file, then, well, they replaced the source code. So they replaced the project file, and that's how the build process was compromised. So that was a very, very different level of sophistication. But when you compare it to some of the most recent ransomware cases, specifically the biggest pipeline of the United States, and the group that was behind it, which was DarkSide, FireEye did a pretty cool report about the tools, the tactics, techniques, and procedures that they use, as well as the tools. And you can see that the Gulf in class is quite different when you compare the two. So you can see a lot more open source tooling, and you can see that it was much more noisy. You see CVE 2021, 20016, which is the SonicWall CVE, I think, and then of course going down the road, plenty of open source tools: Bloodhound, PowerView, Mimikatz, Beacon is Cobalt Strike. So very different, but also a detection opportunity in each step. So going back to the initial slide that I shared, what exactly are we dealing with here? How do we deal with a threat like this when we have such a short timeline? I mean, it takes a little more than an hour just to get your asset inventories in place. How do you manage to remediate a ransomware threat? So what's important to note that the operation tempo will almost always vary between a ransomware group and a cyber espionage group. So the ransomware group will always prefer speed because they will want to break in, encrypt everything, and then leave that ransom note and then just leave. But the cyber espionage groups, of course, they require stealth. They need to stay in. They need to be in the network for very, very long term. So they're looking for the long haul. So the point here is that the operation tempo is always polar opposite for both. And this is even more interesting because some of the modern defensive tech that we're seeing these days relies a lot on baselining what the normal is. So a lot of this technology, once you install it and once you place it in your network, it takes 30 to 90 days just to observe. It learns what normal looks like in your network, for example, or on your endpoint. And then after those 30 or 90 days, if there's a very obvious anomaly, then it'll just ring the alarm bells and say that, okay, this is not normal. This was not something we observed in the 90-day window. And so this is something that you should investigate. So this means that the trend going forward will force attackers to operate slower. And the questions that you will then need to ask yourself is that if the ransomware groups start operating slower, if they ditch their smash and grab approach, and if they dump the noise, and if they start operating in a more sophisticated manner and start being more similar to the cyber espionage groups, then would you be able to see this change in behavior? Would you be able to detect and respond to it? A good case study or a war story, if I may say so, from one of my red teams was that a very popular attack that red teamers really love is the Kerberos attack, and we'll get into the details of Kerberos very soon. But the point is that this particular image is from Debug Privilege on Twitter, and he said that if we look at these Kerberos requests from a defender's perspective, then this is an OPSEC failure by the attacker. And OPSEC means operational security, so the attacker wasn't being stealthy. And what the author is trying to say is that if you just look at the number of requests that were made in that short time frame, so 7:42 a.m. from 4 seconds to 5 seconds, there are plenty of requests, and this is not normal, and that is why it would raise the alarm, not because the request was made, but because it exceeds the baseline by, it just goes through the roof. So how do you detect? What kind of detection strategies can you implement? This is one that I really like. This is one by Jared Atkinson. And he says that attacker tools are just an abstraction of the capability of that tool. So defenders need to start looking at tools as just as an abstraction of the capability. So if you're talking about Kerberos, which is an attack that involves Kerberos ticket granting service tickets, without getting into a lot of detail about Kerberos, the attack itself can be performed by many different tools, so it depends on how you want to perform the attack, but ultimately you need to break it down into what managed code is called, what is the Windows API function that will be called, and what is the RPC call that will be made, and on the network, what is the kind of traffic you'll see. And if you're able to break down the tool that attackers used into the building blocks of it, then you can very well detect any of these tools. Then it doesn't matter if someone builds something custom. It doesn't matter if someone uses, let's say, Rubius, and you have, if you have detections in place only for PowerShell because you have AMSI or whatever, then you won't just rely on that one layer of defense. So you have to break it down into, you have to break down the tool, or you have to view the tool as just as a larger wrapper of the capability itself. One of the other detection strategies that Jared also mentions is the funnel of fidelity, and this is one that I really like because it's very realistic, and it's very obvious that these are genuine problems that he has faced, and the whole world faces these problems. And the problems are that, well, everyone has finite resources, and everyone has finite number of SOC analysts, everyone has finite number of incident responders, and of course finite number of hours in a day. And there is absolutely no way that you can analyze 1 million events. You can probably hire 1 million people, but those, I mean, that is just, it's unthinkable. So the idea here is that the funnel of fidelity is the funnel of the data that you receive, and every single event that takes place cannot be investigated. So every step in this funnel simply serves a purpose of taking input and filtering it and passing it on to the next step and making it easier for the next step to analyze whatever it is that you're giving it as output. So when you're detecting events, then you need to filter them out into, if you're detecting 1 million events, then you need to filter them out to only the hundreds that need to be triaged, and then from those 100 you have to pass them on, you have to pass on even fewer to the incident responders to investigate. And if you see that there's a legitimate threat, then you pass them on and remediate those threats. But the idea is you do not clog this funnel. You keep filtering and passing it on to the next step. Some of the most commonly used commands that we've seen, and this is very helpful information from the Japanese CERT team. And one of the other detection strategies that come from a very famous red teamer, Sub-T, Casey Smith, and he said in one of his Black Hat talks that behaviors happen over time, and we need to monitor where the action happens. So we need to be able to look at the larger picture. And from a red team perspective, of course, we know that attackers pay a lot of attention to blending in. So pay a lot of attention to legitimate binaries being renamed and replaced. So things like PowerShell.exe being renamed to p.exe and put somewhere else and then being run from there. You need to be able to detect very simple and silly things like those. Network connections from living off the line binaries, so binaries like msbuild and regserve32, so on and so forth, also worth looking at. And of course, frequency analysis, that is something you should be performing just to have a good idea if there's something odd that shouldn't be in your network that's sticking out like a sore thumb. So if there's a schedule task that has been created only on 10 computers out of 100 computers, then that's probably something you should look at. Okay, in the interest of time, I'm going to speed up a bit. This is a pretty cool picture by, it's a slide by Florian Roth on how to prevent ransomware. He focuses on low effort and high effectiveness measures. So those are definitely something you should prioritize over anything else that the sales team might be trying to sell you. And that's where I stop. I'll be on Slack when this is being played. Of course, this is a pre-recorded talk, so feel free to ask me questions. Thank you so much. Dankeschön, merci, gracias, grazie. Happy to present, and thank you once again to the BSides team.
And we are back. So Sajal, thank you very much for the nice talk that you had. And now we have time for a quick Q&A session. The first question that I see, I think it's a brief one. So Guy on the chat asks that SolarWinds look like a process injection. Was this the case?
So if by process injection you mean that the attackers had to query the remote processes to see if the specific project was being built, then I wouldn't call it process injection because that's a different technique that attackers use. But if you are familiar with the technique of spoofing command line arguments, then yes. So what that entails is you have to read the PEB of a remote process, and the PEB of any process has a lot of attributes like the command line arguments, what modules are loaded, and so on. So what happened with the SolarWinds case was that the malware itself was able to read the PEB of the MS build process, and that means that when you read the PEB of that process, then you can see that MS build would have those specific command line parameters, and that's how they identified which particular project to hijack before it was built. So if you want to read up further about this, then there is now a lot of documentation about how to spoof command line arguments and how to read the PEB. So I strongly recommend that you could go through those.
Good tip. Thanks for that. Then one other question from P in the chat. He says, if Cobalt Strike is so heavily signatured, how is it used anyways in attacks? Why is it detected right away?
Yeah, so that's the sad reality of it. Cobalt Strike by default, like if you just run Cobalt Strike without changing anything or modifying any of the settings, or if you don't use a C2 profile, or if you use a C2 profile that's straight out of someone's GitHub, then yes, popular vendors or popular security technology will signature you. But if you are able to customize it to eliminate some of the default behavior, then it's significantly harder to detect. And then you'd have to rely on other detections. So defense is always layered. So first you have static signatures for default settings. If that fails, then you need to detect on something else. You need to detect on behavior like process injection, for example. And then when you start detecting on such behaviors, you need to detect on specific API calls, which process injection technique should we detect against. So that's it's a lot more complex than saying that, okay, Cobalt Strike is out there and it's available, so why isn't it getting detected? And also most of the victims that we see who are getting ransomed, not a lot of them have proper full-fledged EDR and security teams and a SOC. So yeah, the reality is a lot more different on the ground.
Mm-hmm. Yeah, makes sense. Cool. Then that's all what we can answer right now. I see there are more questions coming in on the Slack channel, so I suggest everyone to join the Slack as well. Again, thank you very much, Sajal, for having the talk at the BSides Munich in collaboration with the AlpSides conference. Really very interesting stuff, and everyone that wants to get in contact with you, as I said, feel free to go on the Slack. Also, we're going into the break now. I can recommend again to everyone, please join our sponsor Slack channels. There are still giveaways to give away, I heard. And also Siemens, actually the place where Sajal also is working, they have some job offerings posted as well. So if you're interested in getting into red teaming, that's one of the options you can look at. So yeah, have a great evening. I hear also that you in Munich as well, the thunderstorm is coming in. Thank you. Have a good evening. Let's get back to the break now, and we will continue after the break with some more very interesting talks coming up. Thank you.
Thank you so much for having me. Welcome back, everyone, to BSidesMesh21. Our next speaker is Henning Kopp. Hey, Henning, great to have you.
Hi. Yes, thanks for the invitation.
As a child, Henning always wanted to become an inventor or a street magician and hitchhiked to Spain. Lucky for us, he instead studied mathematics at the TU Kaiserslautern, specializing in the area of number theory. His interest in cryptographic application then led him to complete a PhD in the area of IT security. He's currently employed at Schutzwerk GmbH, where he performs various types of security assessments. Schutzwerk is also one of our sponsors, so shout out to them and thanks for the support. Today, Henning is going to lead us down the path of padding oracle attacks and explain to us a glaring weakness of block ciphers. So go join the Slack channel if you haven't already and participate by asking questions on padding oracle attacks, the critical bug in your homebrewed crypto protocol.
Hello, and welcome to my talk here at ElbSides. Today I'm going to talk about padding oracle attacks. So first of all, the obligatory About Me slide. I'm Henning Kopp. I have Twitter and I also have a website. Originally, I studied mathematics, and there I specialized in algebra and also in number theory. And then later I did my PhD in computer science in the area of distributed systems and also in IT security. And currently I'm working at an IT security consultant at Schutzwerk. So after that, let's talk about my main focus today, which is the padding oracle attack. So what is a padding oracle attack? Well, it's an attack on a cryptographic implementation where we exploit some additional knowledge of the validity of a padding. And it's kind of a cryptographic evergreen. So, well, the first padding oracle attacks were due to Bleichenbacher and Voddenay in 98 and 2002. And now it comes again every year. So all those new TLS attacks, Lucky 13, Poodle, Drown, Robot, the 9 Lives of Bleichenbacher's Cat, basically all of them are one form or another of a padding oracle attack. And my goal is when you leave this talk, then you will be able to understand the padding oracle attack, and I hope you will also be able to implement a proof of concept. So the magic in the padding oracle attack is basically that it's not an attack on the design of a cryptographic system, but rather on its implementation. So I have seen some padding oracle attacks in the wild with some customers of Schutzwerk where they have implemented their own crypto, and I hope you will also profit from this knowledge and will be able to apply it. So first, let's talk a little bit about the foundation, so to speak. Let's talk about block ciphers. So informally speaking, a block cipher, we have inputs and we have outputs, is kind of a normal algorithm, and the inputs is a block of data of fixed length, which is usually called the plaintext, and also there's a key, which is also an input, and the output is also a block of data of fixed length, which is usually called the ciphertext or the encrypted text. And the security property is that for each key, a block cipher is indistinguishable from a random permutation. So you could also say a little bit more formally that the keys enumerate the space of bijective mappings from plaintext blocks to the ciphertext blocks. So this just means that if we fix a key, then the mapping from the plaintext to the ciphertext is bijective. That means injective and surjective. So you don't have collisions. There are no two different plaintexts which you can encrypt and then get the same ciphertext. So this basically says you can again decrypt it later. Yes, it's just a fancy way of defining it. But usually when you want to encrypt data, you don't have a single fixed block, but rather you want to encrypt multiple blocks. So there are some modes where you can use a block cipher to encrypt multiple blocks. So one is the electronic code book. This is insecure, please don't use it. It's kind of the naive idea that you split your plain text into multiple blocks, P1, P2, P3, and then you encrypt each block with the same key. Why is this insecure? Well, I hope you've seen the ECB penguin. Well, if not, I will explain it to you. So this is an image of a penguin, which is then encrypted with ECB. And when you then look at the encrypted image, you can still see the penguin basically, because well, the background, for example, it's white. So in the original image it's white. And if we look again at how ECB works, then P1, P3, P1, P2, P3, and so on, they are all the same basically because it's just white bytes. And then you get the same C1, C2, C3, and this leads to the repeating pattern here in the background. And so you kind of can spot the penguin. So what we can do instead is the cipher block chaining mode, or CBC. And yeah, it's kind of ECB, but additionally, we XOR the previous ciphertext into the next plaintext block. So for example, here in the second block, we have the plaintext block P2, and we XOR it with the previous ciphertext block before we encrypt it. Then we encrypt it and we get C2. And here this ciphertext block is XORed with the P3, and then this is encrypted, so we get C3. So what do we do with the first plaintext block? Well, there is no C0 basically here, which we can XOR on it. And so we simply, well, basically we invent a C0, which is then called the initialization vector. And this should be chosen uniformly at random. And then this is XORed and treated as C0. And this is then prepended to the ciphertext. Yeah, let's next talk about padding. So usually your message which you want to encrypt does not fit into the block boundaries. For example, your email is not a multiple of 256 bit, but rather some, well, arbitrary length. So what do? Well, simply we fix it so it does fit into the block boundaries. We simply add some bytes, and this is called the padding. And the padding needs to be reversible, because when you then receive the encrypted message and you decrypt it, then you want to be able to remove the padding again. So for example, if you just fill the plaintexts with zeros at the end, so that the whole plaintext, the length of the plaintext is then a multiple of the block size, then you cannot undo it later. You do not know how many zeros to remove. But actually, we don't have to care that much about the padding because there are standards. So there's PKCS5 and PKCS7. There are also multiple more standards, but today I will talk about these. For the others, it's basically similar. Well, there the value of the padding bytes is the number of the added bytes. So the idea is if we have A's, so A in hex is 41, A, and the last block consists just of 4 A's, but then we need 4 bytes more so that we have a whole block. Well, we need a padding of 4 bytes, and the value of the padding bytes is the number of added bytes, so we add 4 4s. So this here in the box is then the padding. Yes, and then we can decrypt it because now it fits the block boundaries. Yeah, here, in this row, it's a second example. So what if it fits the block boundaries? Well, then we have to add a whole block just of padding. Yeah, so now the open question, or the question where the padding oracle attack is based upon, what if the padding is incorrect after the decryption? So we have a message, we pad it, we encrypt it, we send it, and now the receiver receives the message, the encrypted message, decrypts it, And next, he needs to remove the padding. But what is if he cannot detect the padding? If there are not 4 bytes of 4 or 5 bytes of 5, but rather, well, 2 bytes of 4 or something like this. Well, then, of course, the decryption failed. But what should an application do? What should a protocol do there? Should we throw an error or should we not throw an error? And this is basically the main problem where people make bad decisions, which then lead to padding oracle attacks. So I will not answer this now, but rather we will come back to this, but please keep that in mind. So next, another nice observation. What happens if an attacker flips a bit and we're in CBC mode? So let's say we have here this green bit in C2, so in the second ciphertext, and the attacker just flips it. And then the receiver, he gets this message, and then he encrypts it. And of course, if we encrypt this, we get here some garbage. So this is complete gibberish. We cannot understand this anymore. But here we flipped one bit, so the attacker here flipped one bit. So here, one bit at the same position is flipped, this green bit. Yeah, and this, of course, well, there are no changes to P1, right? So here the summary, if an attacker flips a bit in CBC mode, then one block is unrecoverable. The next block has a flipped bit at the same position, and later blocks and previous blocks, they are not affected. So I have a demo here. So first, I'm creating a new file which is called secret.txt, and it consists of 48 A's. So here I have the secret.txt, and it's just A, and so on. And actually, these are not 48 bytes, but rather it's 49 bytes because there's an end of file delimiter at the end. So next, let me encrypt it with this command. Sorry, that was too fast. Rather, it wasn't too fast, but we had a end of line here. Okay, so we encrypt with OpenSSL with AES 256, which is the block length, and AES is just the cipher we're using in the CBC mode. The input file is this secret.txt, which I just created, so the AAAA. And the output file is called secret.cbc, which is then the encrypted file. Then I specify an initialization vector, only zeros. This is insecure, don't use this in production. Well, and then I don't have a salt, which is just some internal thing which we don't care about now. And -p means we're using a password. So now it asks, well, what do you want to have as password? And I take AAAA for A's. AAAA, again, the same password. And this is then the key, which was derived from this AAAA, which I just typed in as a password. And the initialization vector is just zeros. So what does it look like? Cat secret.txt. Secret CBC, of course. So the secret.txt is the A's. Secret CBC is the encrypted file. Yeah, let me copy it because now I'm going to modify it. Let's say secret2.cbc. And now, well, what do I want to do? I want to show you that I'm correct. So I want to flip a byte, decrypt it, and look what happens. So for example, here, there's the 31. So this is the encrypted file. And if I have a 30 here, then I flip one bit. The 1 is now a 0. Next, I have to save it. And now I'm going to decrypt it with this command. Yes, exactly. So OpenSSL. Again, I'm using the same cipher, AES 256 in CBC mode. As key, I'm using this derived key here. The initialization vector is again only zeros. The input is the secret CBC, so the encrypted file where I switched 1 byte. And the output is now called secret, well, can call it secret1 txt, which is then the decrypted file. Yes, and it works. Let's look at secret1 txt. Well, it may be a binary file, but let's look at it anyway. So we have here the A's, A. Then we have here one gibberish, which is exactly the block which I told you about that it's, well, broken then. So one block is lost. And here we have A, and here's one at symbol. And that at symbol is basically an A where one bit is flipped. Okay, so that was basically just like I told you, but, well, why did I make a copy secret2 CBC? Well, there's some additional trick here which I want to show you. Let's now flip another bit. Here we have 6-3, so if we have 6-2, then the last bit is flipped. So I hope this works now. Otherwise I will just edit it out of the video. So now I will again decrypt it. And the input here is now secret2 CBC, and the output is again secret2 txt. And now I get an error. So bad decrypt, digital envelope routines, EVP, decrypt final X, bad decrypt. What is this? I flipped a bit in the next to last block. I try to decrypt it, and then I get this error. So what I did there was I decrypted it, and then I broke the padding. Because I flipped, so if we look back at this part, I flipped it here. So first I flipped it here, and then everything was fine. Next I flipped it here, and then this was broken. So here, this padding here was broken, and this error here basically says, well, I tried to decrypt it, but now the padding is not correct, so I cannot decrypt it fully. So this is a padding oracle. We get information on if the padding is correct or not. And next, we want to use this to decrypt the full file only by having this padding information. And this is the Vodene attack. The setting is as follows. The attacker has the encrypted message of the victim. It's encrypted in CBC mode, and then the attacker can modify the message and send it to a server. And the server then answers if the padding is correct or if it's incorrect. And that's the padding oracle. And the attacker does not get any more information. He only knows if the padding is correct or if it's incorrect. And now what is the impact? Well, I think I've already spoiled it. So the impact of this small information leak is the full plaintext recovery, which is a fancy way of cryptographers to say we can decrypt the whole message, or rather the attacker can decrypt the whole message. So let me show you the main idea, which will hopefully allow you to implement this. Again, I have here this diagram of CBC mode. And now the idea is the attacker changes this last byte. So now not any byte, but this last byte. And then this block is broken. And here, this block, this byte here, the last byte is changed. And well, we give it to the server, and the server says, well, the padding is broken now. So we're doing another change. We try one more value for this last byte here in the second to last block. And for one of the values, well, actually for two. So if we don't change at all, the server will say the padding is correct. But also for one value, let's call it X, the server will say the padding is correct, because then here we have a 0, 1. And 0, 1 is a valid padding, of course. And well, we can detect this by using the padding oracle, by asking the server, because that's what I said as an assumption, that we have a padding oracle. And well, what does the attacker then know? The attacker knows that this value X, what he has chosen, X or the last byte of P3, which he does not know about, is 0, 1, because it's a valid padding. And now we can do basic algebra and say the last byte of P3 is 0, 1 XOR X. So we know 0, 1, we know X, so we can compute the last byte of P3 with this information. And next, we want to have one more byte. We want to have the second to last byte. So if we have here X, XOR 01, XOR 02, then in the encryption here, we should have 01. So we can guess here the next but last byte, and we change it multiple times. And so the attacker changes it, gives it to the server. The server says, well, no, it's not a valid padding. So we try again, we change another, we change this byte to another value, we give it again to the server. The server says, no, it's not a valid padding. And well, we can try all 255 values. And for one of the values again, the server will say, yep, it's a valid padding. We call this value here Y. And for this value, we will have a 02 here. And so Y XOR the next but last byte of P3 is 02. So we can again do algebra. So the next but last byte of P3, this brown thing here, is Y XOR 02. So we are now knowing 2 of the last bytes here. And we can do this for the whole message. First of all, we're doing this for the whole block here. And then we're throwing this block here away and doing the same here and treat this as the end of the message. And well, what's the consequence? Basically, we can decrypt the whole ciphertext 1 byte at a time. And at most, we need 256 Oracle calls per decrypted byte. But on average, we're using 128 calls. So for example, if we have 100 milliseconds per Oracle call, this leads to 12.8 seconds per byte average decryption speed. And well, let's talk about an example where we have session IDs. So a session ID is around 32 bytes long. And 32 bytes take around 6 minutes to decrypt with this bandwidth stated here. And of course, we don't just send a session ID, but in a real world use case, we need some more time for the remaining HTTP header. But 6 minutes for decryption is really fast in a cryptographic setting. So for cryptographers, it means it's broken. Okay, next, let's talk about applications and countermeasures. So this was the Vodernay attack, but of course we can also do a padding oracle attack on other cipher modes. So for example, for the counter mode. Of course, I had now as a padding the PKCS5 or 7, but it also, of course, works for other types of block cipher paddings. The interesting part is this padding oracle attack works independent of the encryption algorithm. And now you may be asking, well, but I'm using an asymmetric encryption scheme. For example, if you're using RSA, which is not a block cipher. What can we do there? Well, there are also padding oracle attacks. There's, for example, the Bleichenbacher attack. Yeah, I will talk about this shortly. It's not necessarily more difficult than the Vodernay attack, but it's more tedious. So first of all, let's talk about what's a padding in RSA. Yeah, RSA has the properties that if we encrypt some value A, and if we encrypt some value B, and if we multiply it, then it's the same as the encryption of A times B. Usually you don't want to have this. And also the next problem is that the encryption is deterministic. There's no random stochastic component like the initialization vector in the CBC. These properties are generally undesired, so the determinism and also the homomorphic property, and that's why we're using padding in RSA. And there's PKCS1 version 1.5, which is just one type of padding for RSA. And the idea is you have the message, and then you pad it as follows. So you have here your message, then you add 00, 02, some random non-zero bytes, and then again 00. You convert this to an integer, and then you encrypt it. Yeah, and this is the padding in RSA. And well, if you want to do a padding oracle attack on it, you're basically iteratively guessing values which you multiply to the encrypted, to the ciphertext basically, and then basically the server says, does the plain text have this? Does it look like this? And from then you can narrow down the intervals in which the real plain text is until the interval only consists of one value. Next, what are the countermeasures against padding oracle attacks? So one countermeasure is you simply don't provide a padding oracle. So you don't reveal if the padding is correct or if it's not correct. But actually, that's very hard because there are multiple side channels. For example, you have timing information, you have memory access patterns, maybe you want to lock your errors and so on. Then the next countermeasure is you can use a secure block cipher mode, which means, for example, you're using GCM instead of CBC because CBC is usually, or CBC can be vulnerable to these type of attacks, whereas with GCM, it's much more harder to have a vulnerable implementation. For the asymmetric ciphers, you can just use elliptic curves instead of RSA, because in elliptic curves, you don't have a padding. And on the protocol level, you can encrypt and then authenticate or sign or MAC, however you want to authenticate with is up to you. So when someone receives the message, he first has to check the signature. And if the signature is not correct, or if the MAC is not correct, then we know, or the receiver knows that someone has tampered with the message. And then he can simply abort. And he doesn't have to decrypt it and thus provide a padding oracle. How does TLS do it? Well, TLS does it the other way. TLS first authenticates and then encrypts, which is the wrong way, so to speak. So if you receive a message in TLS, you first decrypt it, and then you check the authentication. And so if someone has tampered with the message, either the decryption fails because the padding is incorrect, or in a later step, the authentication fails because, well, someone has tampered with it, so the signature does not verify anymore. And if an attacker can distinguish between these two error modes, basically, for example, via timing or via the error message itself, then he has a padding oracle, and then he can try to attack it. And that's why we have Lucky 13. So Lucky 13 in 2013 was a timing attack against the padding. There was Poodle, which was a padding oracle, and also a downgrade attack. There was also Drown in 2016. It was a downgrade attack, and then there was a Bleichenbacher attack on top of it. 2018, there was Robot, Return of Bleichenbacher's Oracle threat, or also the 9 lives of Bleichenbacher's cat. So there we had cache attacks, and via the cache attacks, an attacker was able to distinguish between the basically he had a padding oracle attack because the type of memory access was different. So what were the fixes in TLS? Well, first of all, there's an encrypted MAC negotiation extension for TLS 1.0 and 1.1. That was in 2014. So basically it says, well, I want to negotiate with you that we first encrypt and then authenticate. So we're doing it the correct way and not the bad way. Well, in TLS 1.1, the handling of the padding errors was changed to use the bad record MAC alert rather than the decryption failed alert to protect against CBC attacks. So basically there was a different alert. So the handling of a failure of the authentication or a failure of the decryption via the padding, it should be handled the same. Well, in TLS 1.2, we have in the standard this part. In any case, A TLS server must not generate an alert if processing an RSA encrypted pre-master secret message fails. So we're talking about RSA here and the Bleichenbach attacks in the handshake. Instead, it must continue the handshake with a randomly generated pre-master secret. It may be useful to log the real cause of failure for troubleshooting purposes. However, care must be taken to avoid leaking the information to an attacker through timing, log files, or other channels. So if you're implementing TLS and the processing of the pre-master secret fails, then you're not aborting, but rather you have to continue with a random pre-master secret, and it fails then in a later step. So in summary, what have we learned there? Well, do not use your own crypto in production, but I encourage you to build your own crypto for learning purposes, and also to build your own attacks on crypto, on your own crypto or on other crypto, also for learning purposes. Because if you don't play around with it, then you don't learn. Also, another takeaway is first encrypt, then MAC. If you're building protocols, first encrypt, then MAC. Also, one takeaway is do not underestimate information leaks, because here, basically, the attacker, he knows so little. He knows only if the padding is correct or not. So, thank you, everyone. Thank you for listening to me. Thanks for inviting me to the conference. And if you have questions, please get in touch with me. For further reading, if you're interested in these type of attacks, check out the links here. I think you should have a good start now, and you should be able to understand these papers. So, thank you and goodbye.
All right. Thank you, Henning, for this fascinating talk.
Well, I hope you enjoyed it.
I did. So we have a few questions for you. Are you ready?
Mm-hmm. Yes.
Okay, so
at least if they are not that difficult.
Well, you're the expert, I have no doubt. If the set of characters of the plain text is known, does that change anything? Does that speed up the process?
If the set of the characters of the plain text is known,
yeah, for example, if we know it's maybe it's a text and the language is German or something, does that help?
No, actually not. I don't think so. Maybe there are some tricks, but on the top of my head, I don't know any trick.
Okay. I think you mentioned
except of course if there's a validation on the character set, because then you can have timing attacks, or you can have an oracle if the character set is then okay. That may help you.
Okay, so it doesn't change anything because you said you still have to try all 254 possibilities. Okay.
Yes, exactly.
All right. So I think you mentioned a few real-life examples. The question is, what are the real-world implications of the padding oracle attack? Does it affect current usage of state-of-the-art crypto protocols in a meaningful way?
Yes. So actually, it affects the design of the protocols and also their implementation. I think that's exactly the interesting part of the crypto oracle attack, because you can mitigate it on multiple levels. For example, when you're using elliptic curves instead of RSA, then you don't have that issue basically, or it's easier. And that may, for example, be one argument to use elliptic curves instead of RSA. And also on the protocol levels, the order of some messages is chosen in a special way to avoid the padding oracle attacks. So it's not only for the implementation, but also for the design of ciphers and the design of the protocols.
Okay, so it's not just an academic exercise to show how even little bits of information leakage can weaken security. It's actually something that's used.
Yes.
All right. I think that's it for questions. Let me check. But yeah.
Yeah, so if there are more questions, you can reach me in the Slack or on Twitter.
I was going to say, so you're going to be there. for a while
Yes.
then. Thank you very much again for taking the time to share this excellent talk with us.
Well, thank you.
We will be available for further questions. Any last words? Anything you want to share?
Well, hello to my parents. I think they are watching.
Great. All right. Well, hello from me too. To everybody else, please check out our other sponsors Slack channel for swag and other really cool stuff. And a big shout out also to Airbus, who are sponsoring this year. And thanks for your support. Stay tuned for our next talk. For our next talk, I would like to welcome Sascha Steinbiss and Andreas Herz. Hey guys, great to have you.
Hi, everyone.
Sascha and Andreas are working for the DCSO, that's the Deutsche Sicherheitsorganisation, and they're going to talk about the fascinating challenges of network security monitoring in large enterprise environments, where large means more than 80 high-performance sensors distributed in 15 countries across heterogeneous customer networks. So please join the Slack channel, participate by asking questions, and enjoy the care and feeding of meerkats.
Good evening, everyone, or good afternoon. We are Sascha Steinbiss and Andreas Herz from DCSO, and welcome to a talk about advanced network security monitoring in enterprise environments. We will start off with a quick introduction to NSM, which Andreas will do, and then we'll both share some experiences about the challenges that we've seen running this kind of service, and afterwards summarize the lessons that we've learned over the time. Quick word about our employer. We work for a German company called DCSO, Deutsche Cybersicherheitsorganisation, which is basically a managed security service provider. Founded in 2015 by large German companies and some scientific institutions. And among the set of services that we provide is a cyber defense service set, and besides incident response services and providing that intelligence information, there's also a network security monitoring service, which in our context is called threat detection and hunting. And Andreas and me were both involved in that, and that's the source of our experience. So that would be it about our employer. Let's dive straight into what you came here for. Let's talk about network security monitoring as what it is. Go on, Andreas.
So hello from my side as well. I'm Andreas. So I guess most of you know what an NSM or IDS is, but just to highlight the scope. So with the network security monitoring, you get a comprehensive view of the flows of your network and characteristics, which is not like directly a focus on only security things. You can also compare it to some sort of asset management, stuff like that. But you have a huge variety of information that you can already collect within your network you control. With the intrusion detection system on top of that, You also try to identify malicious communication, policy violations, or anything that's very suspicious within your network. And most of the time, such appliances that are dealing and are providing the intrusion detection system are called sensors. So from now on, when we talk about sensors, that's what we're talking about, a system that's including NSM and IDS capabilities. So the use cases that we have are in general passive network enumeration, so that you get your overview of your infrastructure changes, that you see if any new networks have joined, if new machines, clients have joined, or anything specific has changed, a wall in your network, and you see traffic that you haven't seen before, which might be legit or might be something you think is a violation of any policies. There's also the use case that you try to discover the attempts of any kind of attack, either a malware infection on any system or whatever you've seen that's like ransomware, or specific attacks that directly targeting your company or services that you provide. It's also possible to detect vulnerability scanners, or for example, pen testing and stuff like that, and as well as malicious devices either inside your network, outside your network, that are trying to enter your network and see if they can obtain any data, infect any systems. So a lot of use cases that you can have for using an NSM or an IDS. So when we started this and established this as a service, we had a lot of challenges, roadblockers, and other issues. And we will shine light on what we've seen, what solutions we try to provide, what we've already achieved, and what is still on the road. So from an engineered perspective, there are different challenges in an enterprise environment. You can split it up in like 4 major areas. That's like hardware, the network, data itself, and the monitoring of that. So when you look into the hardware, it's quite clear that you need some sort of specific hardware for that features that you want to provide. So sensor sizing is very essential and has some parts of the network area as well. Performance testing is mostly based on what hardware you have and you have achieved, but also how your network looks like. So they're deeply connected to each other. Same goes with the composition of the traffic itself that you forward to the machine. The placement is crucial. You have some requirements based on the hardware, but in general, you want to look into your network. Where do I place the sensor? Where do I see the most of the traffic? And also, how do I manage those devices? For example, in our case, they are managed by us for the customer, but we need to make sure that we can reach those systems and we can take care of the management of those devices. If you go to the bottom, we see a huge part is the collection of data. We want to analyze the data. We want to aggregate the collected data and also visualize the data. And that's where we're heading forward to the monitoring part, but we also include like the performance monitoring, that we're making sure that the appliances are running as smooth as possible and that we detect any issues either of different traffic changes that might indicate even an attack, or just that there's something wrong with the network that we need to improve the performance. In addition to that, on the data side, you need some sort of security content management, because without any security content, it's hard to match on specific attacks or anything else. So what's often called signatures or ISCs. And hand in hand goes the downstream matching towards this data. So when we look into the challenges specific for the hardware, in most of the environments, you will see 10 to 40 gigabits of traffic. Also some deployments already at the 100 gigabit area, but that's not as distributed or not seen as much right now, because it's only on like universities have networks like that. It takes some time for the enterprise network to upgrade to more faster network connections. And you will have to deal with some sort of requirements by the customer. For example, a lot of customers saying, okay, we can't provide more than 1 unit of rack space. So you need to make sure that your appliance is as small as possible. There's also different variation on what network connection does the customer have. Do they already have SFPs for a fiber connection, or do they still rely on normal copper network cables? You need to make sure that you're flexible enough for your customer, because they have different requirements, but on the other side, you want to stay consistent as possible. So you try to balance those both areas, because if you go too deep into flexibility, you will lose consistency and have a whole lot of maintenance work to do there. Also, what we've seen is shipping restrictions. So it's quite easy to distribute appliances, especially for managed service within Germany or the European Union. But if you start to like have a customer that has on the whole world some data centers, think about Asia, Africa, it's very complicated to have a solid shipping there based on taxes or the customs and stuff like that. So you need to be aware of those restrictions as well. You have to deal with different set of meta selection, that's quite, of course, and the hardware availability. Especially this year, we've seen that it's very hard to get specific hardware. We've seen it on the GPUs, although we know you don't use GPUs on those appliances for sure, but also the pricing of memory and disks has increased, and the availability also as well. So it's a challenge as well. So different solutions came up. So for a 10 to 20 gigabit network, it's totally fine to use one single machine, at least for our use case. You just need to make sure that it has enough power. One of the recommendations is that you use a dual socket CPU system, for example, with Intel Xeon or AMD EPYC are very fast as well, with enough cores to deal with all the traffic that you've seen. And also that you have some sort of capacity for other services that you want to run on your system. So it's not just the detection engine. You have to keep in mind that the operating system needs some resources and any additional tooling you want to provide as well on this machine. You need to be very cautious what network cards you buy. Cheap ones won't serve the performance settings you might want to achieve. So we've seen that only more or less the more expensive Intel cards are good enough that provide specific tuning options and stuff like that that we haven't seen on the less expensive cards. The other option is, but it's very expensive to go with capture cards that are specifically designed for this use case. There are some that are more or less close to what Intel is providing with normal network cards, but there's also cards like those from Napatech that have an FPGA in it, so you can program the NIC itself. But keep in mind, it can be quite expensive, especially if you compare it to the CPU and the memory. What you also will see if you use a dual socket system, that you need to be aware of the numeral clustering. So you can provide very high performance if you isolate dedicated CPUs to a specific NIC and make sure that there's no huge overhead in between. But there's different talks about that in the community as well that go into deep dive and how you need to configure it. And you want a lot of memory because you can store a lot of data in memory. It's very fast, and you should ensure that you have enough memory. So in the next step, we go into the sensor placement and traffic acquisition. So when you want to observe the network, you should ask yourself, is there any central location where most or all of the traffic needs to pass? One example would be a core switch. We would expect to see most of the traffic. You also need to look into what options do you have to mirror the traffic. Do you have any existing tap or span ports that you can use to obtain this traffic? Or maybe do you already have packet broker in place that would provide especially that but where you would like to add those. For example, if you have none of those devices, you need to make sure that your core switch either supports this or that you can somehow get it out of that place and move it forward to a tap or span. And what type of traffic do you want to see? Because you can have a very nice place on your switch, but if you don't see the right traffic, it won't help at all or not much. So we've seen a traffic separation in different dimensions. A lot of customers in the enterprise environment have different VLANs where they like separate specific areas. So you want to make sure that you have the most interesting VLANs included in this traffic composition. You want to definitely see the east-west communication, for example, from specific servers to the DMZ or for compliance to the server or within the server network, especially if you want to go into lateral movement. But you also want to see the north-south traffic, which would be the example for the uplink to the internet or to your cloud or whatever you're using. Ideally, you see both of those directions. And you need to ensure that you place the sensor location that maximizes protocol visibility. In most of the areas, we've seen that you can't get all the traffic, but you can see the most of it, unless you like put a sensor on every corner in your network, but it might not be feasible. So for example, instances or where you have DNS traffic is one of the most valuable information. So if you don't have DNS traffic within the IDS system, you lose a lot of information. But if you have some specific strange protocols that you don't want to investigate at all, it might be okay to leave those out. So you need to do a nice overview of your network. Where do you see which traffic, what protocols, and try to establish the most protocol visibility there. If we look into the network challenges, there are a lot of challenges, but those are the ones we've seen that made us headaches at some point. In general, a big issue is asymmetric routing or traffic that's only unidirectional. It's fine for some protocols like UDP, but in general, if you see TCP traffic, you want to see the whole flow. So we want to see the direction from a client to a server and the traffic backwards, because it's very hard to analyze the traffic if it's not like that. Another issue could be encapsulated traffic. Some protocols are quite easy to decapsulate, but if you have like different layers of encapsulation, for example, GRE, VLAN, and another encapsulation, it's difficult to decapsulate, and also is a huge hit on the performance. So that's an issue we've seen. In general, if you see broken packets, that's always hard to debug, because if like information is missing or it's broken, how would you try to still analyze or identify anything in those packets? We've also seen several setups where non-standard conforming traffic was seen. The most example we have is RFC invalid VLAN Q&Q headers. There's an RFC for a specific VLAN and VLAN embedding, but for example, a Cisco doesn't do it right, like the RFC. So if you have a system that's trying to analyze this traffic based on the RFC, like the official documentation, but it's not showing up like that, it might be an issue for the performance as well, or even detecting some stuff. Proprietary protocols, it's quite clear that if there's no good documentation or reverse engineering, it's hard to debug those protocols as well. And of course, encryption makes it difficult to take a look inside the traffic, but it's an old deal breaker. But you need to just realize that there's no perfect network, and that you need to live with those challenges and try to find the best solution for that. So some solutions came up. Packet brokers are nice. They're quite expensive, but nice. They can fix your problem with the asymmetric routing. If you plug in all the different cables and say, okay, please merge traffic and forward it to our appliance to the sensor, it will solve this issue. It's also possible that the packet broker to filter and bypass specific traffic. For example, elephant flows might be something you want to filter, but you can also filter it on the sensor itself, for example, with BPF filtering. The only thing is that if you do it in hardware, it's better for the performance unless you have to do it on the system itself. Try to decapsulate the traffic before you forward it. This is an option we've seen at several places, that customers were at least had the option to remove some of the VLAN tags that have been in the outer area that we don't want to look at inside. So it was easier to look into the real traffic we want to see. And try to work as best as possible with your customer to improve the network itself. Sometimes we've seen issues just with the NSM, that there's an issue with in the network, not from a security side, but more from a practical operational side. So most of the issues can be dealt with, but not all of them. So when you look into a network setup, what should it look like? That's a very small overview, but those are the options we've seen. So if you have on the top the internet and behind that the firewalls, it would be one option to put a tap device in between to see the north-south traffic on that side, and for example forward to a network packet broker. You can also add additional taps, so within the firewall and the switch, and also to other switches within your network, where you have on the left the clients or on the right side your servers. So make sure that every traffic that might be relevant and should be seen is tapped to a network broker. There we can gather all the resources, or all the sources of the network traffic, do some sort of load balancing, filtering and stuff like that, whatever you like. And for example, you have like 40 gig ingest or 20 gig ingest, you can load balance it to 2 sensors with each providing 10 gigabit of performance. And you can also forward it to a different monitoring system as well, like a copy of the traffic. So you can be quite flexible with that. That's one example how you can do the traffic composition. It all highly depends on your network, and it's also obviously an easy task, but there are different options that you can look into. Now I hand it over to Sasha.
Okay, so before we can talk about the data challenges, we should probably just define what data we're actually expecting from such a system. So probably the simplest piece of data we can get is just simple net flow information. So what host in the network talks to what other host, how much data is exchanged in packets and in bytes, and what kind of protocol was used, TCP, UDP, and so on. That's already quite useful, for example, to identify the top talkers in the network, or to derive communication patterns, and to that make it possible to detect whether two systems that usually do not communicate will communicate in the future at some point. Going beyond that, we usually have metadata, and that usually means specific protocol-specific information that is passed from the observed traffic. And well, that might be interesting just to store for potential hunting, but it could also be aggregated and added to special purpose databases that are usually tuned for a particular task. Like, for example, an asset tracking database that would provide a summary of all the devices in the network and their potential roles, make it possible to derive subnets and their potential properties from there, and so on. That's pretty useful. And you could also do things like passive DNS databases purely on the basis of these metadata. And then leaving the pure NSM area and moving on to the intrusion detection field, there are also alerts, which are based on the occurrence of an interesting pattern somewhere in the observed data. And that usually will then be subject later on to contextualization. So putting this into a larger perspective, usually done by some kind of analyst, and then reporting it to whoever is responsible for security incidents in the organization. So how do these alerts usually, how they are generated? So first of all, there's in-stream detection, and that's usually done by intrusion detection system rules. And rules, as we know them, are written in some kind of language that basically describes relationships between patterns that can match both in the raw traffic, so byte strings somewhere seen on the network, as well as specific fields in the metadata. They can be connected and can be put together into conditions. And they're pretty heavyweight. An example for these are snort or suricata rules, and whoever has already seen those rules know that they are powerful, but are quite expensive to evaluate. There's also the option of downstream alert generation, the downstream matching, and that basically means having a fast set representation of indicators that are just simply matched against metadata fields that match the kind of indicator that we're looking for. So for example, we can have a Bloom filter, which is a probabilistic data structure that allows fast matching allowing for false positives. And then, for example, just match all the HTTP host or DNS RR name entries against the Bloom filter for potential domain indicators. And this is so fast that we are using this to match millions of indicators, whereas IDS rules are usually just a couple of tens of thousands. But it's not feasible, both in terms of memory and of computing power, to have a lot of these rules. We can't have millions of IDS rules in the traditional form. So if you rely on rules and these indicators, there needs to be some way of obtaining them and to manage them. So for rules, for example, there are open source providers like Emerging Threats, Positive Technologies, and so on, that just provide sets of rules to the community at no cost. The commercial providers, Emerging Threats also has a professional offering. There's CrowdStrike and various others. And if you're lucky enough to have a set of analysts or a group of analysts in your organization, they might also want to write their own rules. So having a SCM, a security content management system, is definitely a plus. For Bloom filters, so for the large sets of indicators that we're going to match, usually there are indicator suppliers. Also, there's a huge variety of different commercial offerings. And you could also just use your own sharing circle, for example, via federated MISP installations that could provide you with these indicators. And since there's a possibility of false positive, you also need to have some kind of confirmation server that receives alerts that might be false positives and then confirms them whether they are in the actual database or not. So usually, when we're talking about data processing, there's a bit of a dilemma. We can't really store everything on the sensor in a database because we have space constraints, we have processing constraints, and we can't all send it all home because usually there could be sensors that observe a lot of traffic but only has a very narrow connection to the backend. So the approach that we took was to derive the information that we're interested in as close to the data source as possible. So throw away everything on the sensor that we don't really know, but what we need to put this into a form that we can immediately accept on the backend side. So obviously, that needs some way of operationalizing these steps to have something that, some kind of engine that accepts different plugins or different components that do these work, data filtering, enrichment, and aggregation. I'll show in a minute how we're handling this. And then on the receiving side, set up some kind of distribution engine that allows multiple consumers to get the same kind of data, because at some point you will have multiple components that will need the same data, right? You will have something, for example, that takes NetFlow to you to do one thing, and another that takes the same data to do a different thing. So a distribution engine on the backend side is really, really helpful. And it also makes it possible to scale out the whole thing, right? You can just have multiple consumers sharing the same data source and basically just distribute the data across the same data across a potentially large set of consumers. So this is an overview of how we're doing it and what we've seen to work quite nicely in our context. We have Suricata, which is the NSM engine that we are using on the left side, which takes traffic from the network interfaces on the sensor. And they are taking, as I already mentioned, rule sets and Bloom filters to do detection. And all the data, so both the alerts and the rest of the metadata that the system generates, is forwarded to a software called Fever, which is basically just an engine that runs different components that can subscribe to particular kinds of data that are received by the system. So for example, if you want passive DNS data and aggregate it and send it home, you would subscribe to everything that is related to DNS. If you want to do downstream matching, then for example, your Bloom filter matcher would need to subscribe to DNS, HTTP, and TLS, and so on. And on the receiving side, we're using RabbitMQ to have one exchange per data type that we receive from the sensor. And then we have lots of internal consumers that can just attach to these exchanges, build their own queues, and receive and process the data as they see fit. And we've seen this to work extremely well for our use case. Okay, moving on from the data aspect to a different field. Having such a system is nice, but it's not always easy to debug and to optimize such a system while it's deployed in the field. So we need to have some way of testing such an appliance in some kind of lab, and ideally under real-world conditions. But the problem is that live traffic, as we see it in customer sites, that shows a lot of variation. So almost no customer deployment is alike to the other. Another challenge is that we are usually not allowed to sample any traffic from the customer side to use on the lab side. So we need to have some kind of way of producing a lot of traffic from scratch, out of thin air, really. And then we need to have some kind of way to actually simulate that traffic. So we can't always replay the same things. We might want to have different IP addresses. We might want to have different source port numbers and so on. So there needs to be some kind of engine that respects that and tries to generate real-looking data. And then it needs to be it's necessary to be able to specify a particular traffic bandwidth, for example. So we can generate input data at about 100 megabits, 1 gigabit, 10 gigabits, and even more to match what we expect in a particular deployment. And of course, to cover everything, we want to have at least the most challenging situations available as PCAPs, so we can just get them and run them in the testing setup. So we might just buy one of these ready off-the-shelf packet generator appliances that do this, right? XCR and so on. Well, they're quite expensive. That's 6 figures, probably. And they might not always be flexible enough for everything that we want to do. And I mean, the other end, the lower end, is using TCP replay with a set of PCAPs, but that's quite hard to tune. And also it generates always the same traffic, which might not be realistic enough to actually produce the kind of effect that we want to see in testing. So what we settled on was T-Rex by Cisco, which is a packet generator in software, which is built on DPDK. You can just run that on a regular server with appropriate network cards, and that's actually capable of generating tens to hundreds of gigabits of traffic with just a very small set of example PCAPs that will extend and replay with variations. So we can just use free or anonymized PCAP sets that are available and just vary them enough using T-Rex to match our use case. So finally, there's the problem of monitoring, because we are providing a managed service. That means we need to have some kind of continuous observation of what the service looks like, right? So we want to see, is the service up? What's the system load and the resource usage? What does the traffic look like? Is there anything that stands out compared to other deployments? So what protocols are there? How many metadata do we see, and so on? Do we have a problem receiving packets? So are we actually having visibility gaps just by not seeing traffic? And is there anything in the inspection engine that we can use to optimize the configuration of a particular application? And we are using InfluxDB, the whole tick stack to be exact, and together with RabbitMQ to distribute the data, and Zabbix to do alerting and notifications. So all of the sensors, the Suricata software is writing metrics into the Telegraph agent that runs there, so does Fever, and all of these get sent to a specific exchange in the RabbitMQ, which then forwards the data to an InfluxDB, where we use a capacitor instance to do customized alerting on particular conditions, like, for example, a traffic skew or a machine going down, and then to things like Grafana or Chronograph for drill down and for debugging reasons to actually look at the data. That will look something like this. So for example, here we can see the number of events per second that we process in a particular location, then the distribution of DNS requests, for example, flows broken down by the app layer, so what protocol amounts to what fraction of the total number of flows that we see, and what the distribution of app layer protocol looks like from the proportion side. There's actually already a native support in Telegraph, which was provided by us and which was merged into 2019 into the main Telegraph software. Right, so I'll pass it on to Andreas again to summarize a couple of challenges in addition.
So we still have some challenges pending that we haven't solved completely. Monitoring and updating remote appliances is always a challenge. There's no easy solution for that. Performance is crucial. We still have some setup where we need to deal with packet drops and need to find a solution how to deal with them. As I've said, encapsulated unidirectional probe traffic is always an issue. One big issue that's left is big data transfers and backups, often called elephant flows, because they are like several gigabits of traffic, just one flow, and that's killing performance unless you do something about that. Encryption is an issue, especially if it's end-to-end. It's nice to have encryption, but from an inspection side, it's something you have to deal with. And there's so much room for more advanced debugging tools to get a deep dive onto the system, why something is broken or something is happening. So one solution we came up with, which helped us a lot, that the hardware selection respect of NUMA node locality and high performance is very important and needs a lot of time to investigate what might be the perfect hardware for your fit. One solution would be for the elephant flows to find a solid solution for dynamic flow shunting. We're looking into eBPF options, capture cards, packet brokers that might provide that feature and cutting a big flow at one point where we only see huge payload that we want to investigate. We've started to add customized monitoring for the TIX stack and to combine it with SAVIX. The performance optimizations that we did on the Linux system is using the most modern AF packet version 3. That helped a lot. And make sure that you have symmetric caching and CPU pinning so that each traffic will go into one specific queue on the network card that's aligned to one specific CPU on your system, that you have a whole pipeline that's not really changing for the specific flow, that you reduce the overhead to the smallest value possible. We've tried to, or deploying sometimes the packet broker to fix the issues that we've talked about. And in some areas, we are dealing just with the BPF filter to bypass specific traffic that is known to be an issue and where no simple solution is available. So I'm heading over again to Sasha for the lessons learned.
Right, so one of the things that we found out would be really helpful to get us moving and make us agile enough to try many different things is just automate as much as we can, from deployment to monitoring. That automation was really key to be able to try as many things as we can. Hardware optimization, Andreas already said it, it's really worth it, not just buying anything, but to know why you need a specific piece of hardware and what the specific upsides are. Network knowledge always helps here, so we don't just react, but also try to proactively improve the situation. Since we have machines out there that are not under our control, so we need to have a management connection to actually do anything. We need to make sure and take extra precautions to keep an VPN connection always there, and also, if it's possible, to have some kind of IPMI connection there. That saved us later on a lot of trouble. Right, so monitoring also pretty important. So sometimes you don't just want to react when everything's gone wrong already. We want to see the situation before it actually becomes a problem. So monitoring in detail is really helpful. Right. So I think let's just move on because just the time is already slipping away. Is there any more questions? Just feel free to ask them in the Q&A or just send us an email or hit us up on Twitter. Thanks.
Thank you, everyone. Bye.
All right, welcome back. Thanks for the fascinating talk. Are you guys ready for some questions? I think we have some time.
You're ready.
All right. How long does it usually take until the whole NSM system is in a smoothly running state from the monitoring perspective?
It depends. If the system is racked and online, it can take 1 to 2 days, depending on the customer and all the optimization. But I would guess on the average 1 to 2 days. If you have all the information beforehand, it might be even faster, but that's the average.
Wow. Okay. You mentioned consistency versus customization in your talk. Can you talk about cases where you eventually realized if we do X, it would be too much customization and increase maintenance effort enormously for very little benefit, or the other way around?
Yeah, so we had one example. We forward different outputs and events to our backend, but also there are like questions from customers. Can we have those events as well? And if the customers have one specific format that's only he is using and it's not like standardized, the effort for pre-processing, parsing, and all that stuff might be too much to make this effort for the customization.
All right.
Sasha, you had another example.
Well, yeah, another example would be all these little tuning configuration parameters that Suricata has. And they most likely vary so much across customers that it doesn't make sense to really tune everything perfectly at each individual customer site. So it makes more sense to find one common ground that works well enough for most of them and then stick with that instead of putting more effort into maintaining and somehow taming this complexity. And another example, for example, is something like the assignment of CPUs to individual worker threads. And since this only depends on the variety in hardware sizing, that's something that is just easy to assign, right? So usually we just know that a machine with that many CPU cores or with that particular traffic distribution would usually need that many cores to process the traffic. So that's usually the trade-off that we're going to think about.
Yeah, that makes sense. Another question is, how do you handle encrypted traffic?
So there are two parts. So if we don't have any specific device, we see the encrypted traffic, and then you only get the metadata. You see the TLS event, you see some information from the certificate used, for example, and all the payload later. You don't investigate into itself because you don't see it. You can't decrypt it on the sensor itself, but you have all the metadata, so you can already provide visibility on that. Another option would be that the customer has some devices that already do the decryption, like a man in the middle or something like that, and they forward this already decrypted traffic to the machine. But there is no simple or sensible way to decrypt on the machine itself the traffic.
I guess that's a good thing. All right, that's all the time we have for now. Thank you very much again, Sasha and Andreas, for taking the time to share this fascinating talk with us. If people want to follow you and your work, where can they go?
I guess the best way would be to follow our Twitter handles that you already tweeted for the presentation.
All right, perfect. And you guys will be available for some further questions in the Slack channel. If you have further questions, feel free to ask them. Any last words, you guys?
Thanks a lot for this great event. It was very, very nice.
Good. Please also check out our sponsor Slack channels for swag and other really cool stuff, and stay tuned for our last talk. Welcome back, everyone, to the last talk of the BSidesMEsh21 conference. Our speaker is Jeff Darrington. Hi, Jeff.
Hello, hello. How are you?
Thanks for being with us.
Yeah, it's great to be here.
Jeff is Senior Technical Marketing Manager at Greylog, one of our sponsors this year. So thanks for the support. Jeff actually grew up with IT security before anybody knew what it was and how important it would eventually be. In his talk, he will give us a short overview of what Greylog is and what it can do and how log management can help secure your network. So go on and join our Slack channel, the Slack channel for the talk, if you haven't already. Participate by asking questions and enjoy Jeff's talk. Log management keeps your network secure. Real-world examples.
Hello, I'm Jeff Darrington, the Senior Technical Marketing Manager here at Greylog. I'm happy to be here with you today. I'd like to take the next 15 minutes or so and talk about a few things. A little bit about the history of Greylog, why I joined Greylog, and how great of a company it is to work for, and a demo of some network security, physical security, and some identity management. I will be opening up the floor for Q&A at the end. So let's get started. First of all, a history of Greylog. Greylog began in Hamburg, Germany in 2009 as an open source project for log management. And the idea was to offer IT ops and DevOps teams, security teams, a platform to have centralized log management. Moving forward to today, Greylog's headquarters is in the United States in Texas, and a second office in Hamburg, Germany, and a new office as of 2021 in London, UK. Greylog now has thousands of installations worldwide. A little history on myself and what brought me to Greylog. I've spent a little over 25 years of my career in various roles in technology. An early start in physical security and surveillance systems, and then a 10-year career in the telecom and networking with Nortel Networks in support, and a shift to solutions in QA testing. With the demise of Nortel Networks, this brought me to the large county government in the area, where all my past experience paid dividends in wired and wireless network engineering and deployment and firewalls, VPN, application networking, and database management and telecommunications. I came to a crossroads in my career where I was really missing product development, testing, and the ability to contribute to a company building a solid product. I had already been using Greylog for quite a few years, so I started crawling LinkedIn and websites and came across Greylog hiring. And well, the rest is now in the history books. I decided to leave the county government I was working at and hang up my pager and on-call and put my time and efforts into something that I had a lot of passion for. And all of my career paths and experience have led me to here where I am today. And Greylog is a great place to work. And with so many changes around the world regarding remote work, I've been able to join Greylog from Canada. Technology changes so fast. Not to date myself, but it's come a long way from being on a modem at 300 or 1200 baud rate and downloading information from a bulletin board service to dial-up internet with a blazing 33.6 baud rate internet. Now with cybersecurity, software development, applications, cloud, and IoT, all with constant cyber threats, we're all kept on our toes. Now let's look into a few things that keep security at the forefront. First, I'd like to talk about physical security. Many people in IT ops and operations think about physical security, things like locked doors, card access, CCTV cameras, and possibly 24/7 security guards in heavy secure areas. There is another level of security. All the systems and procedures are usually all independent systems. I'm wondering, has anyone here today thought about your physical intrusion systems or card access or CCTV and guard patrols? And if you have the knowledge of them in your central log management platforms. This is where I'm coming from on this topic. Most, if not all of these systems now have the ability to send their event data to a central area. One being, for example, a centralized log management platform like Greylog. Think of the information you'll have at your fingertips if you know when people are coming and going from your building, if they've been seen on camera, or if there are intrusion alarms and guard duty walkthroughs. Now let's look into an instance of Greylog. Here's a Greylog instance capturing card access data from the security system from multiple locations, and it's been logged for the users and includes the departments, the physical location, the geolocation, and if they have badged in or out of those individual locations. In this search, some representation of staff by numbers of staff in or out or within a ratio of staff by department in this pie chart. Now, to think about this data for a second, some use cases for this information in high security areas would be used for fire drills or alarms if people are in or out of the building. And they could have been used for last year of pandemic regarding logging in and logging out for work to keep track of your staff, or ensuring that you've kept track of your contact tracing. In addition, correlation for staff when they're in and out on holidays, or correlations of network logins and arrivals, or strict onboarding and offboarding of employees where login accounts are being disabled and physical cards keep things in check. If you're disabling user accounts, you'd want to ensure that within the predetermined amount of time frame within your policies that you'd want cards disabled. So correlating events could be following these informations from all these systems. Once you're monitoring that layer 1 or step 1 of physical security, it's important always to maintain constant awareness of what's going on in your network. Many of you know monitoring things like malware, spyware, viruses, monitoring your traffic flows internally and externally, and known internet destination threats. These are all standard approaches to understanding what's going on in your network. And to highlight this in my Graylog instance, I've got a dashboard here to just go through regarding the Palo Alto Spotlight. And in this, we have a Global Protect tab, which includes things like successful and failed logins and authentication over time, and of course including your GUIP for these events as well, which is very crucial in many different traffic flows to understand where they're going to and from on a map. Gives you the indications of what's going on in your network. The next tab for URL filtering, this is all your web filtering rules and understanding where everyone is going and what they're doing on the network. What might be some threats regarding individual web transfers or anything going on outside the network. A dashboard showing you that constant flow of web traffic over time and showing you the different categories, what's going on, and include there as well a GUIP map things. The next tab we'll go through is the traffic logs, and traffic logs are important for having unique individual sources for destinations and external sources and having them mapped out as well in GUIP, and showing dashboards with the traffic over time, understanding those peaks and valleys throughout the day, throughout the time frame. Obviously, if you're an 8 to 5 type business and your traffic flows tend to be at a certain level, looking at these values, in the middle of the night in your time zone, all of a sudden the traffic goes through the roof. There's a clear indication, there's something or an anomaly going on in your network you'd probably want to understand. And other things in this list are with heat maps with traffic, so you're understanding what those high talking applications are or what's going on with individual users. So it's another good way of actually showing that in the. And moving on to the threat logs. So threat logs give you that alert and level of alert for low, medium, or high virus or vulnerability or spyware capability within the Palo Alto, so you're able to see it. And the inclusion again of the GUIP of the destination locations and source locations of these. Very importantly, the users in the network and threats detected activity in your bottom here. If you've got a particular user that's been infected in their environment with malware or whatever type of virus they might have, obviously if it's transmitting data at a high rate or things are changing rapidly with that individual, you're going to have your severity counts by user and let you hone in on that user and find out what's going on. That's what we have for our network security. As you can see, you don't have a centralized log management platform for network security. It can be very cumbersome. Many environments that you are able to monitor from past experience, you may not be at a point where you have all the same firewalls and all the same products to have them centrally managed. So you're in a transition period, or you're in a place where you can't monitor all destinations with a centralized location from a given platform. Central log management is agnostic to those platforms. So if you've got different vendors in your market and you unfortunately can't move to a single vendor to make things easier, that's where central log management really plays key in monitoring multi-vendor environments in your environment. When monitoring things deeper into your network at the endpoint client level, you're able to collect even more valuable information. An example of this is with Sysmon and Windows operating systems. In this example in my Graylog instance, we're logging Sysmon events through the Graylog Illuminate Spotlight for Sysmon. This gives you detailed information and in the Windows endpoints, such things like recording hashes for image files, process GUIDs for correlation of events when Windows reuses process IDs, GUIDs for some logon sessions, logs for drivers or DLLs with signatures and hash values, raw read access to disk volumes and events from early stages in the boot process, and many others. Some, if not all of these, very well common, in fact, are those for looking for data in your logs for IOCs and hash values, looking for known and bad DNS queries and bad IP destinations. They're very common within these actual environments. Modifications of files and known directories or file names that are being modified in many different threat vectors. In this instance of Graylog, I've highlighted here the dashboards that are available specifically to Sysmon, one being an overview and the other three being the investigation drill downs for host, for process, or for user or login activity. This will highlight individual workflows and tracking those individual items one by one in investigations. Next tab we're looking at here is the primary dashboard, the overview, and includes 4 different pieces of information or 4 different tabs within the dashboard. The first one is the DNS summary, showing you the failed DNS queries and successful DNS queries, and over time, and a variety of successful accounts and their path, as well as the top 10 or rarest 10s right across the board. The next tab, we've got a Sysmon endpoint activity summary, and this one gives you the endpoint types of events that are being listed and provides you a heat map for the top 10 endpoints and Sysmon types by host, and the subcategories broken down as well. The Sysmon network summary tab is a tab that allows you to see the network connections that are created and processes and whatnot by Sysmon and its monitoring of those. So here you'll get the top 10 destinations by ports for the destination IP addresses, and you can map backwards as to what's going on in your individual endpoint clients. And a Sysmon operations summary, which just gives you your hosts reporting, your Sysmon errors detected, and some events over time for the subcategories, so you can get a good snapshot of what hosts are being involved in the Sysmon data. And with that, that ends our technical overview of the demo. And now we are going to move to question and answer period.
All right, welcome back. Thanks, Jeff, for this really great talk and for rounding off this wonderful day of conference at the end. We have a few questions for you. I hope you're ready.
Definitely.
All right. Well, one question is the software still open source?
Yes, it is, and it will maintain to be open source.
That's good to hear. And can I run Graylog on my home network Raspberry Pi server?
I would say definitely yes, as I have an instance running on a Raspberry Pi myself.
Okay, good. Are you also running your own magnetic keycard system?
I'm not, but I have a lot of experience in that area. I do have an alarm system and a lot of logs coming into my Graylog instance.
Oh, nice. All right, great. So maybe you can make a talk next time about your home Graylog system. Now, if putting more and more data, ESP physical, into a centralized system, won't I create a very juicy target for bad guys as well? Knowing who is leaving when a building would be treasure for an SE attack. That's a good point.
Yes, that is a good point. And as a side note, we would be just duplicating logs that are being already stored in existing security systems. So typically those systems have a given attack surface themselves and are vulnerable to whatever operating systems or vulnerabilities they may have themselves. It's very common that those systems are Windows-based systems. There's very few Linux-based security management systems. There's many different flavors in software for the different types, whether they're web-based interfaces or a thick client base, but the attack surface would remain the same for those systems. So you would want to ensure that you're following your best practices and securing those and securing authentication to them. It's the same as Graylog, you know, securing your authentication with multi-factor authentication and, you know, following good practice all the way around as far as your security and access. But it is true. It is definitely information that's valuable and from both sides of the spectrum. And that is from the attack surface, but also internally. So you know your organization very well and who's coming and going.
All right. So always protect your data.
Mm-hmm.
If I was returning to my office tomorrow and wanted to use Graylog, how would I get started?
It would depend. I'm going to flip that question around. I hope I can get back another one. It would depend on what your title or your position would be in your organization. I've been asked that question many times. And obviously, to start, you can download the current issue that we have, load on our software. It's open source based. So depending on your organization's policies on spinning up new open source software, obviously you'd have to cater to what your organization's policies are and your standards to be able to have it set up and deployed. I've actually had it set up multiple times, our OVA or Docker set up on a laptop to experiment with it so you can take it anywhere you're going and learn it. It's a good learning platform. I've got about 3 different instances running. I've got a hard server, I've got a Docker version, I've got an OVA running on my laptop. So I can take it anywhere and demo it anywhere or utilize it. Getting started, one of the videos actually on our website, on the resource website, is getting started with Graylog. There's one particular one called Feed Your Graylog. And that video on our resources page actually walks you through getting Graylog up and running and working with a Windows endpoint client and a Linux endpoint client, and how to set up the inputs for the 2 different log types, one being FileBeat and WinLogBeat, and sending log data into Graylog and configuring that up through Sidecar. So it's a really good get to start right quick with a configuration so you can view information in Graylog.
All right, awesome. Yeah, that's a good answer. Where can I learn more? Probably what you just said, the Graylog website.
Yeah, there is another level of learning with our Enterprise Edition. If you purchase the Enterprise Edition of Graylog, we do have our Graylog Academy, which is our actual formal training. And Abe Abernathy, our trainer, has set up a large intensive lab, and you are brought into the classroom. There's a number of different courses that we are offering, and Abe will run you through ground up configuration of Graylog, as well as sending log sources in through some scripted tools that we've built to be able to emulate different kinds of log sources, and then walk you through setting up parsing rules and pipelines and creating searches and dashboards and alerts and a variety of other things. So it's a very comprehensive way of learning Graylog from the ground up.
Awesome. Thanks. Unfortunately, that's all the time we have for now. Thank you very much again, Jeff, for taking the time to give us a great overview of Graylog. And if people want to follow you and your work, where can they go?
They can follow the Graylog Twitter page or my personal handle @JivePig, which is a little hacker name that I used to work by. And the other thing is it was great being here, and I really appreciate the opportunity to present today.
Great. And you will be available for further questions in the Slack channel.
Absolutely.
So everyone, feel free to bug him. Any last words? No.
Just like I said, it's said for me again, great being here today, and I really appreciate the opportunity. It's been a great session.
It's been great having you. Thanks everyone for joining and participating. And thanks to everyone who helped make this conference possible. If you can, fill out our feedback form to help improve the next BSides and ELBsides events. And please check out our sponsor Slack channels for cool stuff and giveaways. They will be up for a while, so feel free to hang out, ask more questions, and get to know the sponsors a little bit more. That's it for now. I hope to see you all again the next event, whenever it'll be, hopefully in person. Bye. Are we still on? Great.
So,
yep, I'm still on as well.
Yeah, so everybody, we're going to get together for a bit of a beer bash. I'm going to try to get everybody online. This is operations. Let me see, let me get me online. There we go. Let's get everybody else online. Let's see. Let's get Jeff back again.
The gates.
Yeah. So that was that was the. Oh, sorry. Did I just stop somebody's video?
So unmuting helps actually to say hello.
Yes. Let's get everybody online.
Ooh. Hi, Stefan.
Moin.
Moin. So let me see. Looks like we've got everything. Now I need to go into grid view.
Okay, who gets the beer?
There we go. So
actually, I look actually a little bit bad with the beer today.
Well, you don't have beer?
I actually don't have beer right now. No, but I have actually very good water here.
I need to get one. I'll step away to get what I was gonna get, but I'll be right back.
Okay. So yeah, right. Well, I see that Andreas still has his pseudo beer. Or is that real beer in the meantime?
Pseudo beer.
Now it's real beer.
Now it's real beer. Oh, cool.
The same bottle.
Because what you guys didn't see is that he was drinking iced tea before.
Good choice.
Coffee for me.
Coffee. Okay, yeah, it's early in the morning for you.
Oh, I have coffee. I have
it would have.
yeah.
It would have been. It would have been my Das Boot.
Yeah.
Oh, that's a real good.
All right. Cheers.
Cheers.
Nice.
Cheers.
Cheers. Cheers.
At least the glass is the right one.
Yep. Yeah, this came right from Germany. My wife brought this when she came back from Germany.
Oh, nice.
Lowenbrau, Munichen.
Anything else already?
Sorry, you can't hear. Oh, Dagmar couldn't hear. So sorry. Hang on. Let me just change it over to speakers.
Okay, well, no.
You are. Let me just put on the.
So if we're doing this again virtually next time, maybe we can integrate some kind of video hangout for the participants, maybe. Because I thought that was a surprising amount of fun just hanging out on video.
Yeah, that would be a good idea. I think that's something we could consider. So for everybody in the audience, yeah, next time around, if we have to do it virtual, then let's add some video component for you guys as well. Otherwise, if we do it hybrid, we'll also try to think of something to do.
You can check out Discord then. I just recently got it after we decided to use Slack, because Discord is nice. Well, you can have those rooms with video. So, but let's hope we don't need to do it virtually again.
I hear you.
Hi, Thomas.
Minimum hybrid.
Hello,
yeah.
everybody. Hi, Thomas.
Yeah. Post.
Yeah. So that was real. That was BSidesMesh21. Does everybody remember how we got to the name BSidesMesh21?
I think it was something about fishing and like individual.
I can actually. I know it actually.
Yeah. I think Max probably knows it.
Yeah, we had actually a few ideas and we meshed it basically together. It was actually based on the idea that we actually do B-Sides as a service, but we cannot do B-Sides as a service because this was last year already the point. So we thought a little bit around and we're like, yeah, okay, so we have actually two areas where we are working together. So we're actually meshing together. And that was one of the basic ideas. So we had a few other things like, yeah, we could integrate it like a shell because the SH, for example, is also included. And it's also including Munich and Alpside somehow. So
it was also because there was like B-Sides München M, and then Elbsides E. So B-Sides S, E, and then we have the SH or so as well. Yeah. It was very deep and layered, very, very deep.
Very security focused, right?
Yes.
Very security focused.
Very.
Actually, at the time, I was working on a threat model for service mesh. So yes, it was actually security.
That's
related.
true.
Have not tried
yes, there is this. If you look into Istio, the standard installation you can read from the Istio.io homepage is completely flawed. So don't. and the hack is trivial if you know IP tables rules and how to revert them. So
Yep. It was a really cool threat model. I won't go into more depth than that. That's all. So yeah, mesh rules. Yay, team.
Yes. And we'll see you all hopefully in the flesh, as they say, next year.
So no mesh, only flesh.
Oh, yes.
Oh, we already have a title for next year.
From mesh to flesh.
Yeah.
That'll be that'll be the registration form. It'll be register mesh or flesh.
Yeah, will be a mesh or a flash participant next year.
So basically, after the conference,
I'm gonna
is
say
before
cheers
the
to that.
Jen, you
You're
rock.
welcome.
Planning started already.
Yes. What do they say in German? Was it nach dem Con ist vor dem Con?
Nach der Con ist vor der Con, yeah.
That's not German, is it?
Nach dem Spiel ist vor dem Spiel, or?
Yeah, it can be applied to multiple things. So.
Okay.
Yeah.
Okay.
And thanks, Max, for all of your input. And that you're our backup, just in case everything fell apart over here. That was a great relief to know that I'm not on my own.
Yes. I actually was all that. No one actually know it besides of the people in the planning. But actually we had 2 areas where we work together. So we have actually one hosting for Munich, which is actually Nuremberg. Hello.
Yeah.
And the other one in Hamburg, which is actually the setup from Martin. So that in case that something actually happens, for example, the very good internet in Hamburg is actually down for reasons. There's a second person who can actually overtake more or less seamlessly. So,
Yeah,
but we have
I
not
guess
seen
Nuremberg is close enough to Munich anyway. So
Yeah,
that's
as we are, because we're in Wedel. We're actually in Schleswig-Holstein. So kind of the logo with the SH, which is the initial for Schleswig-Holstein, which
Besides
is next to
Wedel, okay.
Hamburg. It's kind of cool, but...
I heard you had a hailstorm in Hamburg. Is that true?
Hailstorm?
Yeah,
When?
yeah.
Where?
I just got my boss who's outside of München said that it had total hail at just
Oh
before.
yes, it did. It was crazy.
Yesterday it was very.
It was heavy there, hailstorm, everything all together.
Yeah, the sky was lighting up yesterday.
Okay, so it must be something regional to his area. That they got
But there was also in Munich, but not a hailstorm, at least not where I am. There was a short storm.
I thought you said head store, and I was like,
a store.
No, but you have IKEA store, so I know that.
Oh, Gustav, I was wondering whether maybe in the future, when we're naming vulnerabilities, whether we could name it after IKEA furniture.
Oh,
right?
Oh no.
No.
I would love that.
And then you already have
the Billy vulnerability.
And then we can say that we contribute to the security community.
Well, we actually need an IPT group with the name of that Vulcan in Iceland. Was it Iceland? With this extremely long name that no one actually. That actually no one can actually talk about it and be like, yeah, it was the Vulcan one, you know.
Volcano, yeah.
Yeah. We know. We nearly got stuck in Munich and needed to go back to New York, and yeah, that was difficult. That was in 2010.
Can you guys share a few numbers, maybe? I'm very interested in how many people were watching, maybe at most, or...
We'll do that offline, because at the moment I'm just seeing us actually being online, more or less. But I think that's wrong, because the way these things work, the way the statistics work, it seems to be a little bit curious. Maybe Max and me can figure out exactly how many people were online at various times. So
yeah,
we will definitely send out the report. We always do this after the events, like with statistics, how many people participated, links to talk, saying thank you to sponsors. So everybody will receive.
For the report. Very good.
I've done all the past ones, so I guess I can
You've
also do
done
that.
very good reports, indeed. Yeah.
Anna.
Thank you.
Oh, and I have a question. Since we had the Star Trek versus Star Wars, I know that some of us like licorice. Who's on team licorice?
Not me.
Ben is on
I didn't get it.
Licorice? Do you like licorice or not, Max?
I'm like, what?
Lakritz. Oder contra Lakritz.
Just say no.
Yeah,
It's
exactly.
a
Say no.
I think it's a northern thing. I've noticed.
Oh, I like
that.
it.
Yeah. Okay.
It's good.
Okay.
Okay, maybe you're more Hamburg than these units.
No, I'm actually trained. People and friends know actually, but I started at a specific point to give my current location to the train because people were very much not sure where I'm living right now. There are still people thinking I'm living in Hamburg. Other people think that I'm living in Berlin. Other people think that I'm living in Munich. So,
that's,
you know, if you're trying to trick Google, into not knowing, you know, what you're doing and what you're up to, just realize that Anna works for Google, so so they know anyhow.
No, so Google is fine. I'm fine with Google. That's fine.
All right, we should probably wrap it up. It was great. And I'll see you guys next year.
Yep.
Can't wait.
All right.
Thanks, everyone.
Thanks, everybody.
Thank you.
Bye.
Bye.